I'm sure you've had an idea for an app you never built. The kind that stays in your Notes app for 2 years, or that you mentioned to your friend over a coffee. The one that you opened up a tutorial for and then closed it as soon as you saw the stack. Most ideas die there. But AI changed the math. Because the gap between I want to build this and it's already running on my phone is now just a weekend and not 6 months. Most AI demos that you see on YouTube or X show you how to spin up a toy project in 20 minutes. You finish it, then try to build something real, and the whole thing falls apart by the third feature. Vibe coding doesn't survive contact with anything serious. Over-engineering is even worse. 2 days of planning and writing architecture docs for an app with 0 screens. Both approaches are how nothing gets built. This video sits in the middle. You're going to build a full Duolingo clone in React Native, using AI the whole way through. Onboarding, sign up and sign in with email, plus social auth, language selection, lessons, profile, and a real-time AI teacher that you can actually talk to out loud.
Please repeat after me. Hola.
Hola.
Nice start.
You speak, it responds, back and forth, like practicing with someone who's always around.
Try hola with a clean O sound, like hola.
Hola, hola.
That was much better.
You won't write a single line of manual code. You also won't just YOLO the prompts and hope it works. The first part of the video teaches you the workflow. I'm calling it practical vibe coding. Structured enough that you never lose track of what's in your codebase, but fast enough so that you actually ship. The second part is the full build. The stack: React Native with Expo and TypeScript, Nativewind for styling, Zastant for state management, Clerk for auth and user management, Stream voice agents powering the AI teacher that responds in real time. 9, 10.
Just one small tweak. 10 is DS with a soft yes sound, not DS.
PostHog for product analytics, and CodeRabbit reviewing every AI-generated PR before it merges. But the app isn't the point. The workflow is. And if you stick around for the second half, I'll show you why this is the only way to build mobile applications with AI without getting lost in all that spaghetti code. So use that workflow that I'll talk about in the video, which you can also get as a reference guide. I'll leave the link in the description, and use it on anything you build next. Now, grab some coffee, Red Bull, or tea, and let's go. Earlier this year, Andrej Karpathy, one of OpenAI's founding members, posted about something he called vibe coding. Fully given to AI. Don't read the code, describe what you want, and let it happen. The dev internet split. Half the replies said this is the future, and the other half said it's how you build something that nobody can ever maintain. Both replies were right. If you've actually tried to build something real with pure vibe coding, you know how it goes. The first 3 features fly, and then around feature 5, you ask AI to fix one thing, something else breaks, you ask it again, and now you're staring at code that you didn't write in a project you can't fully explain. Speed without direction always lands here. But the other extreme looks completely different, but ends up at the same place. Days of planning before a single screen exists. Folder structures, color tokens, architecture docs, naming conventions, and pattern libraries. Hours of prep work for an AI to maybe build something one day. It feels productive because you're typing a lot, but the app never gets started. You're essentially preparing for a battle without ever fighting one. So, what's the middle ground? It's a method I call practical vibe coding. Keep the speed of AI development and add just enough structure so that AI knows what it's working on and you don't lose track. Build feature by feature and verify each one before moving to the next. And this whole method runs through one file. It's called the AGENTS.md, a markdown file at the root of your project. It tells the AI how your project works, what stack you're using, where files go, and what rules to follow before you say anything else in your prompt. And it's not written for you. Tools like Cursor, Claude Code, and Windsurf read project files for context, and that agents.md file is the first file they read. Without it, you'd end up writing the same context lines into every prompt. Same stack, description, same folder rules, same use this and don't use that. And the moment you forget to repeat one, the AI fills the gap on its own. It picks a different state library, a different folder convention, or a different styling approach. Across 20 prompts, your codebase ends up looking like 5 different people built it with 10 different architecture patterns who never talked to each other in the first place. So then, what is the agents.md file made of? First, a role. You're an expert React Native plus Expo engineer. You write clean, simple code. You prioritize clarity over abstraction. That paragraph alone changes the quality of everything that follows. Then you give it a short overview. What the app is, what does it do, and who uses it. One paragraph is enough here. The stack. Every library and service, one line each on what it handles. This stops the AI from suggesting alternatives mid-build. There's also the folder structure, where screens live, where components go, and where state lives as well. The styling rules on what approach you want to use, your color tokens, or any quirks, like Nativewind doesn't work with safe area view, for example, so write that down. And finally, the patterns to follow. Anything you'd otherwise have to repeat across different sessions. And you don't have to write this perfectly up front. You write what you know and then update it when something keeps coming up. Like when Nativewind gave me trouble with safe area view, I added that rule to the file. And then after that, the AI never made the mistake again. So solve it once, document it, and then move on. Now, the full agents.md file for this project specifically comes later in the build. And it's on the GitHub repo too. But if you want a reusable template you can drop into any project and make it work with it, plus the rest of the practical vibe coding workflow as a written reference, well, grab the free playbook linked in the description. But now let's talk a bit more about how we're going to actually prompt. So once you've got the agents.md file, what's next? How do you actually use it? The file handles the project context, but the prompt handles what you're trying to build right now. And this is where I see most developers get it wrong. They type a few sentences about what they want and hope the AI figures out the rest. Sometimes it works, and more often the output looks close, but it isn't quite right, or it breaks something else that was working, or I've seen it introduce a pattern that doesn't match the rest of the codebase. And then you waste another 20 minutes explaining what went wrong. So the fix isn't a longer prompt. It's a more specific one with the right structure. So every single prompt that we'll write together for this project has the same 4 parts and in the same order, starting with number 1, and that is to point it to your agents.md. Say something like, read the agents.md first and follow it strictly, every single time without exceptions. Because AI tools don't automatically remember what they read in previous sessions. So these 2 lines force the file back into the context before any code gets written. And that strictly matters too, because it signals that the rules in that file aren't just suggestions. The second part of every prompt is one task. State exactly what you're building. One feature, one screen, one integration. Not something like set up Nativewind and build the onboarding screen and add authentication. That's 3 prompts merged into one because it felt efficient. But trust me, it isn't. If something breaks across 3 tasks, you can't tell which one caused it. So stay scoped to one thing per prompt. The third part of every prompt are constraints that protect what already works. And again, most devs skip this. Every feature you've built so far is working. But unfortunately, the AI doesn't know to leave it alone unless you say so. So add lines like, do not change the screen design. Preserve the existing UI exactly. Keep the existing stream audio flow intact, and don't expose any secrets in the mobile app. These tell the AI what not to break. They're your working code's institutional memory, written down so the AI treats it as something to work around, not to refactor. And finally, the fourth part of every prompt are design references. If you're doing something visual, attach that image or screenshot or pieces of the design. The AI reads layouts better than it reads descriptions of layouts. So one image will save you 3 prompts of you explaining margins. So put together, a real prompt looks something like this. Read the AGENTS.md first and then follow it strictly. Implement the onboarding screen as shown in the attached design exactly using the assets from the assets folder. Add a navigation link on the home route to open up the onboarding screen, and use the mascot logo image for the top logo alongside the app name. Do not include the pagination dots, and then also drag and drop the image design. It's short, scoped, has a constraint, and has a reference. The AI knows what to build, what not to add, and what it should look like. And I've also prepared a prompt template that follows these patterns alongside more examples in that free playbook down below, so that you can reuse it across any kind of project to give your AI more discipline and structure. Once again, the link is down in the description. And that was the 4-part prompt structure. But now, let's talk a bit more about constraints. Even when I taught developers the structure, they still got wrong the constraints part. Because you can prep the full agents file, you can write the task, attach the design, and then write a constraint that doesn't actually constrain anything. And that happens because most devs are thinking about code when they should actually be thinking about behavior. You don't need to tell the AI how to write the code. It'll figure it out. What you need to tell it is how the feature should behave. What's already working that should stay the same, what's allowed to change, and what's off limits. Some examples that you'll see later on in the build, so definitely make sure to stick until the end, look like this. If anything is unclear, ask before implementing. That stops the AI from making decisions on its own when it hits ambiguity. Also, do not expose any secrets in the mobile app. Keep the existing stream audio flow intact. That protects the security model and the already working integration. And I came up with these just by looking at the app the way that a product engineer would. What could go wrong from a user's perspective? What might the AI accidentally change that's already working? Write those things down into the constraint part of the prompt. Okay, so now you have that 4-part structure figured out, and you know that constraints have to be about behavior. But not every feature has a design. Some are about state management, auth logic, or backend integration. There's nothing visual for you to attach or drag and drop. So how do you prompt for those? Well, again, just describe behavior. First, we have the usual read agents.md file and follow it. Then you tell it something like integrate the language selection state. Store the selected language using Zustand, that's a state library, with React Native async storage. That's going to be our database of choice. So if an authenticated user has no selected language, route them to the language selection screen. And then only after the selection should they reach the home route. Preserve the existing UI exactly. And we can also add a temporary button on the home screen to clear the async storage so I can actually test the flow. The first part is the behavior of how we want our users to be able to use the app. And that last line is a development utility that you'll remove later. So remember, prompt for the infrastructure that lets you verify the feature, not just the feature itself. And what about cases where the AI itself is the problem, where it just doesn't know the current version of the thing you're using? This is incredibly common with libraries and services that update fast. The AI's training data is months behind, sometimes a year, so it generates code that looks right, but it uses a deprecated method, an old API, or a config pattern that just changed in the last major version. You won't notice these changes until something breaks at build time or in production. And the fix, thankfully, is simple. Just paste the current documentation directly into the prompt after the instructions, separated by a divider. An example would be something like replace the mocked auth flow with real Clerk authentication. Keep the existing UI and navigation intact. Implement email signup, sign-in, social auth, and verification through Clerk, and then after verification, navigate to the home route. And then after all of that, simply paste the Markdown Clerk docs, which you can copy over from their website. That way, the AI will read your instructions first, understand what you're trying to build, and then uses the docs to do it correctly with the latest version of the API. And you can do this for any library where you're not sure whether the AI has the current version. And there's also a cleaner path for libraries that publish official skill packs, and almost every dev tool nowadays does that. You simply need to install the agent skill once, and then the AI will keep using the right version automatically without you needing to paste the docs every time. Expo, Clerk, and Stream all have them, and I'll teach you later on how we can install those agent skills for any tool you're using. Another option as well is to use something like Context 7, which also brings back the latest version of documentations for any tool you're using. But again, if you stick along throughout this video, I'll teach you how to use all of those in practice to make sure that your agents always have the latest info. But even that is going to be just the beginning of what we are about to teach in the Ultimate AI Agentic course that's coming soon on jsmastery.com. I've been working on that one for more than a year now, analyzing how to work with agents and the best way to make the most out of them. So if you haven't already, I'll leave the link down in the description to sign up for the waitlist completely for free, so you can access it first and at the most affordable price. I'll leave the link down in the description so you can join the waitlist. And now, let me tell you a bit more about how to prompt when something in your application breaks. I mean, even with this full structure that I'm giving you, things will break sometimes. That's not a failure of the method. It's just how software development is. So when something breaks, the response is always the same. Write just one targeted prompt fix. Something like, the verification model is appearing behind the keyboard on iOS. It should sit above the keyboard. Don't change any other modal behavior or layout. You don't need to re-explain the feature. You don't paste the codebase. You state the problem, state the correct behavior, and then add a constraint if needed to keep everything else untouched. So this means one problem, one fix, and one verification. And that's it. That's how you can prompt well. So finally, let me give you one sentence that ties all of it together. A perfect prompt is just an instruction with a defined scope. And the scope is three things: what you're building right now, what are the works that you're not touching, and what rules the AI already knows from the file. Once those three are decided, the prompt almost writes itself. AGENTS.md handles the rules, the task line handles what's new, and the constraints handle what's protected. And you can eventually add a design reference or a doc paste if needed. That's it. So build the onboarding screen, see if it works, move on. Same for the sign-in, the language selection, and every other feature to follow. And then when something breaks, it's contained because you only changed one thing. If you build this way, which I'm going to show you how to do later on in the build, you can apply it to anything else next. The product will change, but the workflow doesn't. That's the actual skill. And that's what you're walking away from watching this video until the end. The workflow that you'll learn here runs on any stack. But here's the one that we're using for this build. So let's get it set up. For authentication and user management, we'll use Clerk. The developer experience for React Native and Expo is honestly really clean, especially for OTP auth, sessions, and protected routes. You can do it fully custom or enable their pre-built components. But on top of the developer experience, the second biggest reason why I go for Clerk is their pricing. They have the most generous free plan that I've ever seen, where you can have up to 50,000 monthly retained users per app. That's actually more than you need for most MVPs, startup projects, and even fully ran businesses. And then the thing that makes it a no-brainer are their billing features. On top of Auth, you can immediately add billing to your app so that you can monetize it and actually start making money from your app. So click the Clerk link down in the description, create your account, and then create a new application on their dashboard. You can call it something like JSM React Native. Then for the AI teacher part of the application and the real-time lesson experience, I'll teach you how to use Stream alongside their new and fully open source Vision AI SDK. The Vision agents is exactly what we needed for this build, as they allow you to integrate low latency voice and video AI agents, which is perfect in this case because your conversation when learning language should feel like you're talking to a real person in real time. Getting started with Stream will be super easy, especially thanks to their agent skills, but just so it's even easier later on when we do end up using it, go ahead and click the link down in the description and create your free account. You can sign in with Google or GitHub, and you'll be in and get your API key and secret, which we'll use later throughout the build. We'll also use PostHog for analytics, because as you continue building more serious products, understanding how your users interact with your app becomes really important. Things like lesson completion, retention, and feature usage will help a lot over time. So PostHog combines analytics with session replays, feature flags, and product insights, all in one, dare I say, very developer-friendly package. And that's the thing that I love about PostHog the most. They're not trying to speak to some huge corporations, but rather, this hedgehog speaks directly to us, developers, working with their tool. So I'll leave the link down in the description below, so click Get Started and create your account. Then later on, I'll teach you how to use their PostHog wizard to automatically install and set up PostHog within your application. And that's it for the crash course. Very soon we'll dive into the build. And just a final reminder before we get started that I also wrote up everything you learned about in the last 10 to 20 minutes as a free playbook. The idea, the design, the stack, the AGENTS.md with all the prompts and templates included, so that you can also integrate it within your upcoming projects, not just this one. For the final time, the link is in the description if you want it on hand while you build your own apps even after this video. So finally, let's start building the app feature by feature using the practical vibe coding workflow. Let's build it. To get started developing our great application, we'll start from bare beginnings by literally creating a new empty folder on our desktop. Call it something like Duolingo clone, and then simply drag and drop it into your code editor. Throughout this video, I'll be using VS Code. I like using it because of its simple interface to interact with your agents. There's a simple chat built in, as well as Cloud Code extensions that work natively with whichever agent you're using. But don't worry about that for now, as I'll show you exactly what you need once we actually start building. For now, I want us to generate a new application from scratch manually. Head over to expo.dev, then switch over to docs, and you can get started with a simple command: npx create expo app at latest. So just copy it, go back and open up your integrated terminal, paste it in, and add / at the end, which will create it within the current folder. It'll download and extract all the necessary project files, and then run npm install so we can immediately run it. So give it a minute. And then when it's done, you'll see a screen that looks something like this, telling you to run it for either Android, iOS, or the web. Or what you can do is just start the developer server by running npx expo start and then pressing enter. This will fire up the Metro bundler, which compiles and serves your React Native code. And then you'll see a QR code and a couple of keyboard shortcuts below. You can press the letter A to open up Android Studio, I for iOS Simulator, R to reload the app, or J to open up the debugger. We'll use a few of these as we build. And in this course, I'll also teach you how to set up and run the application on your Android Studio or the iOS Simulator through XCode. But to get started with, the easiest way to develop with Expo is through Expo Go app on your phone. It's a mobile app that lets you preview your project on a real device by simply scanning this QR code. Doesn't require any full builds, and you get real-time updates as you save your code. So simply open up your Google Play Store on Android or the App Store on iOS, search for Expo Go and install it. Pause the video, go ahead and do that now, and then come back. It should literally take a second. Once you download it, simply log into your account. And if you're on an Android device, you'll have to scan the QR code directly from within the app itself. If you're on iOS, you'll need to simply open up your camera app and then scan it from there. And if you're on iOS and it's not connecting, make sure that your VPN is turned off and that your phone is on the same Wi-Fi network as your computer. So once you scan it and open it up, it should look something like this. From this point onward, at all times, you'll see exactly what I'm seeing on my real physical device that I hold in my hand, but you can see it on right here on my screen as I'm casting the full device, so that as we're developing different features, we can see what's happening in real time on my screen. For you, I would just recommend to hold your device in your hand and then test it out manually while you develop. Now, Expo generated a lot of different files for us right here. Plenty of different files and folders that we don't necessarily need to start with. But we don't need this generated boilerplate code that says welcome, try it, explore it, and so on. So we can do what the step 3 says. And that is to open up another terminal and simply run npm run reset project, which will ask you whether you want to move the existing files to an app example folder instead of deleting them. In this case, simply say no, and let's delete them permanently. The Expo Go app might ask you for some additional permissions, and since the project reset has been completed, you have to rerun the development server. So head over into our initial terminal, press Ctrl+C to stop the server, and then once again run the npx expo start command, which will restart the server. And then you can press the letter R to reload the app on your phone. And now there's just a blank screen, allowing you to head over into app, index.tsx, where you can edit it and make it say something like Duolingo clone. You'll see that the changes will be reflected in real time on your phone. And with that, the Expo setup is done. We have everything we need to start developing our app. So in the next lesson, let's immediately set up that agents.md file that I've been telling you so much about throughout the crash course. As you learned in the crash course, the next step after deciding the tech stack and setting up the project is creating that agents.md file. So right here in the root of your application, create a new file called agents in capital letters .md. Then head over to the video kit link down in the description. And if you scroll down, you'll be able to see the snippets to copy part, where at the top, there's going to be the agents.md file, which you can simply copy. Once you copy it, paste it right here, and then we can go over it together so you understand how it looks like specifically for this project. And the reason why we're not writing it by hand together is that I didn't write it myself either. The entire process of how I came up with this agents.md file and how you can come up with agents.md file for your own upcoming projects is within that playbook linked in the description. But it's basically a conversation with an AI to generate it. Still, let's go over it together so you can understand exactly what is happening. And we can go through it together in the preview mode, which will allow us to read it just as text. So the first thing in your agents.md file is a role. You tell the AI what kind of developer it should be for this project. Sounds small, but it's not. A general purpose AI will give you general purpose answers. The role acts as a filter. Every suggestion, pattern, and line of code will get shaped by it. For this project, I wrote expert React Native engineer, practical learning project, clean and simple, prioritize clarity over unnecessary abstraction, and think like a senior mobile developer, but explain and implement like someone building a practical learning project. So before anything else, just ask yourself, who would you want to work on your project? What should they care about? And what should they avoid? Then write that at the top of the agents.md file. Now, after the role, give the AI everything it would otherwise have to guess. A short overview of what the app does and who uses it. Like we're building a Duolingo-inspired AI language learning mobile app using Expo. The app teaches users languages through interactive lessons that may include video or audio-based teacher lessons, chat-based AI tutor lessons, vocabulary review, local XP and lesson completion, and more. The goal is to teach developers how to build a modern AI-powered Expo app feature by feature. Then we dive into the stack. Just one line for every library that we use. This stops AI from reaching for different state libraries halfway through the build. A bit about the development philosophy. In this case, we're building feature by feature. And for every feature, we want to first understand the user request, check this file before coding, keep the implementation simple, avoid over-engineering, prefer readable code over clever code, and build the smallest useful version first. Only refactor when repetition or complexity appears, and keep the app easy to teach upon and explain. We also dive into some decision-making and clarifications, where I tell it that if something is unclear or could be improved, I want it to proactively suggest better approaches, and if a new library would significantly simplify or improve the implementation, then recommend that library, clearly explain why is it useful, and ask the user for permission before adding or installing it. And agents thrive on examples. So here I give it an example of this could be implemented manually, but using React Native reanimated would make animation smoother. Do you want to add it? And then only if we say yes, it does. If not, we tell it to not install or add any libraries without user approval. This is a little thing that I add to my agents.md file that makes a huge difference. And I think I also provided it in that playbook below, so you can copy it and use it for all the other projects. Then we dive a bit into the architecture guidelines, how to structure the app, what each folder is all about. This was generated with AI by following the Expo documentation, how it generates images, and then most importantly, the styling rules. In this case, we're using Nativewind and Tailwind CSS for classes. We don't want it to use the native style sheet unless it's not possible to do a specific thing with Tailwind CSS class names. I also give it some information on how it can build from a specific design image, and we'll ask it to reuse some stuff from globals.css if it's already there. We ask it to specifically use the Nativewind version installed in the app by checking which one is available in package.json. And then a bit below, you can see this style exception rules. This is a real example from this project, where Nativewind, the styling library we'll use here, doesn't work with safe area view, which is another library which we need to nicely contain everything on all the screens. You'll see that on it, the class name prop just doesn't work. And this is not something that I know right off the bat. This came up during development of a previous React Native project I've built. Specifically, that was this React Native Full Course 2026, which I would highly recommend that you watch before this one if you still want to learn how to develop some things manually and understood how React Native and Expo work behind the scenes. Watching both of these videos together will give you the full understanding. But yeah, once I saw this, I decided to add it to the agents.md file for all of my upcoming React Native applications, which means that you will not just create the agents.md file at the start of your app. Rather, when something comes up during development, and that keeps reappearing on all of your prompts, you want to just add it to the agents.md so you don't need to repeat yourself. That's the mindset. When something keeps coming up, you put it into the agents.md file once, and you never deal with it again. But yeah, the Agents.md file for this project has things specific to this app: Nativewind exception rules, image centralization rules, stream and Clerk specifics. But none of it applies if you're building something else. So this isn't a template to copy-paste. It's a reflection of your decisions. Take the structure, take the mindset, and fill it in with what's actually true for what you're building. And if you're building a simple notes app, you might just need a role, a short overview, your folder structure, and a couple of rules. And then add more only when you need to. But yeah, make sure you have this agents.md file, not within the app folder where I made it. That's a mistake. It has to be within the root of your application, because that's where the agents will look for it. And alongside this main file, we'll also set up a few skills for some services that we'll be using. Agent skills are an open source standard, which you can think of as a reusable instruction pack that teaches your AI agent how to perform a specific task or a workflow. For this app specifically, you'll need to set up Expo skills, which will tell your agents how to work with Expo the right way. So you can open up your terminal, do it in a new window, and simply run npx skills add. That's how you add any skill. And in this case, we're installing Expo skills. I'll zoom it out so you can see it a bit better, and press enter. Press Y to install the skills installer. And then together, let me show you which skills you need to select. You can use the space key, not the enter key, to select them. So let's start with building native UI. This is useful for building beautiful UIs. Then we'll get EAS update insights, Expo API routes, Expo CI/CD workflows, Expo deployment, also Expo dev client. Then we'll get Expo Tailwind setup, native data fetching, as well as upgrading Expo. And then press enter. You'll then see that this works universally for the following agents, like Codex or Cursor if you're using those. Same thing for Warp and OpenCode, Gemini 2. And then you can also add it manually for additional agents like Claude Code, OpenClaw, and so on. So select the one which you think you'll be using and press enter. For the installation scope, project is going to be fine, and we can do it through Symlink, which is a recommended installation method. So just say proceed with installation. And that's it. Finally, once that is done, you can stop your server and rerun npx expo start one more time. And this means that you have successfully set up and understood how to create your agents.md file. In the next lesson, we'll start using that agent immediately to set up Nativewind, the best way to style your React Native applications. Throughout this project, we'll use Nativewind. And what it does is it simply lets you write Tailwind CSS classes directly within your React Native apps. So if you've used Tailwind on the web, you already know how to style mobile apps. Same utility classes and same mental model. In this case, we're going with Nativewind v5, which uses the latest Tailwind CSS features. Depending on when you're watching this video, it might still be in pre-release. But the core principles, the classes, and the workflows are stable. And if anything changes, it'll be minor file paths or configs, not the way you write styles. So while you're going through the docs, make sure that it is set to v5 here and here, not v4. Then head over to the installation part and press this copy button, which I always love to see in new DevTool documentation pages, as it allows you to very quickly move over that doc page to your agent. Then head back over into your VS Code and let's write our first prompt. The way we'll be doing it throughout this course is by pressing Command or Control Shift I, which is going to open up the integrated Visual Studio Code agentic development window. Now, it doesn't matter which agent you go with, because the interface is more or less the same. I'll expand it right here so you can see it better, but whether you use Copilot, Claude Code, Codex, or something like Cursor or Windsurf, they all work the same way once you're inside. So this video is completely agnostic when it comes to the tool. The thinking and the specs are what actually matter, and the tool is your call. That said, I understand that many of you are wary about the budget and the amount of tokens that it consumes. So here's my recommendation on how you can get most done with spending the least. I'll be using Claude Code, specifically set to the Sonnet model with thinking turned on, since this is what we use internally at JSM and what most people are running these days. For that, the Claude Pro plan should be more than enough, which is about $20 a month. Now, if you occasionally hit limits on that plan, you can merge it with OpenAI's Codex Go plan, which is just $8 a month. So if you want the budget option, and if you don't want to go for Claude Code at all, OpenAI's Go or Plus plans are perfect. And they're usually giving away a month for free, so check that out. And if you're already paying for something like Cursor, just use that. Either way, I'll make sure that you don't burn through a ton of tokens regardless of what you pick. So go ahead and open up the chat window. Then, as I said, you can just press Command-Shift-I to open up the chat window within VS Code. And what I like about it is that it's not locking you into one agent. You can use the built-in Copilot CLI, or head over into the Extensions tab and then search for something like Claude Code, which has like 13 million downloads. Or if you prefer OpenAI, you can head over to Codex and install the Codex extension. Then, to switch between them, just open up the same chat window that we opened up before, expand it, and you'll be able to see all the extensions right here. They're just within different views. Or if you prefer using it within the terminal, you can do that too. You just need to run Claude within it, and it'll open it up. And for the longest time, I was a CLI guy, but Claude VS Code extension has gotten so good that I've recently switched over. It works the same way the CLI does, just with a nicer interface. So that's what I'll be using going forward. And one thing worth pointing out is that there's a little microphone button at the bottom of the input. You can either tap it or hold Command D to speak your prompt instead of typing it. You'll see me do that often. So let's write our first prompt together. As you learned in the crash course, the first part of the prompt will be to tell your agent to read the agents.md file first and then follow it strictly. And then we specify what we're doing within this specific task. And in this one, the goal is to set up Nativewind in the Expo app by following the Nativewind documentation that we'll provide just below. So use the installed Nativewind version and apply the required config, globals.css setup, Babel and Metro changes, TypeScript types, and the app entry imports as needed. Do not use the outdated setup steps or different versioning docs. And then don't forget to copy that docs page. Make sure that it says V5 right here at the top and just paste it right here. Once again, for the best output to token spend limit, I'll be using Sonnet with the effort set to high and thinking turned on. Now, hopefully, you were typing this prompt along with me, or maybe you've paused it and written it in your own words. But this course isn't really about typing. It's about understanding what we're doing and why. So if you don't feel like typing every prompt out yourself, you don't have to. In the video kit linked down in the description, I'll drop every prompt we use throughout the rest of the course in a zipped folder. So if I'm moving too fast and you just want to follow along, grab them from there and unzip them somewhere in the root of your application. That way, you'll be able to copy the prompt for every feature, paste it in here, so you can more closely follow along as I'm explaining it. But yeah, you should already know the structure of our prompt based on the crash course that you watched. They'll all start with the same first sentence, then we have the feature, and then we can optionally drag and drop some designs or documentation pages. And another pro tip is that whenever we finish implementing a specific feature, you'll want to close your window, reopen it, and then start with a blank new session. Don't reuse the old one, because stale context from earlier work will leak in and confuse the agent, and also spend more tokens. So stay in the same chat only when what you're about to do is tied directly to what you just built. And yeah, there's going to be plenty more of these tips within the Ultimate Agentic course. But for now, I think we are ready to run our first prompt. So go ahead and run it. The first thing that the agent will do is it'll read the agents.md file and explore the current project structure. Once it reads it, it'll check the current app structure, And once it does, it'll say that it has everything it needs, and it'll proceed with installing Nativewind v5 with its dependencies, and then set up all the required config files. So I'll allow it to install what it needs to install. It'll proceed installing it. Then it'll ask you whether it can check the Nativewind versions that we're using. So I'll allow it. It'll figure out that the v5 preview is available. And since the docs provided are for v5, it'll install the correct version. And then it'll proceed to edit the config files to set it all up. All steps are complete, and then it gives us a summary. This summary is super useful if you want to dive a bit deeper into exactly what the agent did. And in most cases, it's going to be enough to understand what happened. But if at one point you need additional explanations of exactly what the agent did, you can always just ask the follow-up questions to explain specific pieces of code. I'll show you how to do that later throughout the build. So let's actually test it. It says to rerun npx expo start and add the class name props to check it out. Go to your terminal and rerun your npx expo start and press the letter R to reload the app. Then open up app and index.tsx and modify this view not with a style, but with just a class name in the same way you would a regular React application. So I'll give it a flex of 1, justify center, and items-center as well. And then we'll have a piece of text that will give a class name of text-xl, text-indigo 600 to change its color. We can also do text-center to center it, and I'll give it a margin top of 90. That's it. Nativewind has been set up successfully. And we did it without having to manually go through every single one of these commands and setting up the config files. If you think about it, that's the dirty work. That's the manual work that developers used to have to do, but no longer have to. Because nowadays, we can just prompt our AI agents and let them do the boring stuff, while we can focus on thinking about the app architecture and which features we wanted to have. Great work so far. In the next lesson, we'll dive deeper into setting up our design system. Now, before we start building out some features, let's set up our design language and get all the assets. You can head in the video kit link down in the description and then click the assets button right here. Here, you'll see a couple of folders. The prompt design references that we'll be able to drag and drop to make our prompts more specific. The prompts themselves, so you don't have to write everything I'm writing, rather you can just follow along. And then finally, the actual assets. So for now, let's go ahead and download the assets, then unzip them and drag and drop them into the root of your application. And in this case, we just want to copy the folder into the workspace. The assets already exist, but that's fine. We can replace it because we're going to include the new ones. Within it, you'll be able to see the font that we'll be using across the application, as well as a couple of images, such as this Earth icon, the favicon, the mascot that we'll be using. You know how Duolingo has their own mascot? There's also going to be the palace and some other streaks and treasures that our users can unlock within the application. And believe it or not, I used ChatGPT image generation to generate these different design systems by telling it to create a design system similar to that of a popular language learning app. So what we're going to do next is get access to the prompt materials by downloading them and then drag and dropping it in. If you open up the prompt materials 01, you'll see a design system right here. Again, this was generated by AI by just giving it some information on how I want our app to feel and behave. We came up with a couple of primary colors, a couple of semantics like success and warning colors, as well as neutrals, and then the text font sizes. Now, believe it or not, this is enough for an AI to generate an entire design system off of. So we'll use this as a design reference that we're going to pass into the prompt. So go ahead and open up the chat window again. Again, you can use whichever agent you want, but what matters is that we don't reuse the previous session. Instead, go ahead and click this Start New Session button right at the top right, which is going to open up a new session. Then within it, we'll start by telling it to read the AGENTS.md file and follow it strictly. And then we can start by telling it something like implement the full design system using Nativewind based on the attached design theme. And this is what we talked about in the crash course, but now we're going to do it for the first time together. You can simply refer to a specific design or image or anything, put it within your application files and folders, and then simply drag and drop it in. And sometimes you might need to hold the Shift key while drag and dropping to attach it as context. Then we can tell it to set up the global CSS utilities, separate design tokens in the theme folder, and font and loading config for the app. Finally, ensure that everything is as is shown in the attached design theme that we provide right here. So press enter and let's see how it does. It'll first read the agents.md file and the design system image that we shared. It's doing exactly as it's promised. Then it's reading the current project structure so it can figure out how to implement the theme within it. And then only after it analyzes everything, it'll implement the design system across all the required files. This includes the globals.css, the constants and theme with all the design tokens, the images with centralized image exports, the app layout to load the Poppins font, and then finally the updated metro config with Nativewind input option. So let's give it some time, pause the video, and I'll be right back. And finally, when it is done, it is even asking me to run the linter for me to check for errors. So I'll always allow it to run specific commands like the linter so that we can verify that everything is done cleanly. And as it says, clean. Here's a summary of everything implemented. It changed the globals.css, implementing the full design token layer. We definitely want to check this out in detail. And there's utility classes for different typographies like the heading, line height, and everything else. The backgrounds as well. The colors, font families, and everything for TypeScript. The constant images, fonts loaded, and this globals.css put into use. So let's go ahead and go through all of these files together. First, we have the global.css, and take a look at how neatly it implemented all of this. It imported Tailwind CSS utilities, and then it documented and created the primary colors, like the color lingua purple, there's deep purple, success, and so on. So this is wonderful. And it even simplified the use case by allowing us to just refer to a specific heading like typo, as in typography, H1. So this is great, and it'll definitely simplify the further development of the application. So what do you say that we give it a shot? I'll head over into our app index.tsx, and instead of all of these class names right here, I'll just use typo H1. Restart the application if needed, and take a look at this. This looks so much better than what we had before, but of course we want to center it. So for the time being, I'll just give it a margin top of 90 to put it back in the middle, as well as text center. And don't forget that there's also consistent colors. So if you head over into your globals, you can see the color lingua deep blue, for example. You can just say color lingua, and then you'll see all of our colors, such as purple, deep purple, and so on. And if you don't feel like using this BEM methodology with typo __ every time, you can just ask it to simplify it. So right here within the chat, you can say, let's go with simpler naming for our utilities. No need to include typo and 2 underscores before a specific H1 or H2. Instead, just make it simpler for me to refer to these utility classes. And I think this should be enough. This task should be pretty simple for it to figure out. So let's give it a second, and it should update this part immediately. And there we go, it did it. It just renamed it to H1. And now if you head back over here, you can now just more easily type H1 as the class name, and you can see that everything will remain as it is. And you can easily switch over to H2, H3, and so on. And for the colors, I want to keep this lingua here because we need to know that these are the custom colors that we'll be using. And if at any point you need a more detailed explanation of exactly what's happening within each file that got generated, or you just need more clarification on top of what I already explained, you can always write a follow-up message to this initial prompt where we generate some stuff with something like explain each generated file for this feature in detail, including the reasoning, architectural choices, and design decisions behind the implementation. Of course, this is super detailed, but you can just ask it, tell me in simple language, what does this do? Let's see how it approaches it. Detailed breakdown coming right in. The globals.css is the single source of truth for the entire visual language of the app at the CSS level. We have some imports, then we have the theming, the colors and how they're being defined, as well as the utility blocks, which combine multiple styles into a single class name that we can very easily reuse. There's the constants, which is needed because Nativewind class name doesn't work on every React Native component, like safe area of use, for example. So when you hit those components, we still want to ensure to use the same JS constants and not CSS strings. Better than hard coding the values, right? Then there's the constants images, where we can easily import all the images, the layout, where we simply load in the fonts, and the config, where we say that we want to use Nativewind to actually make it work. Cool. So with that in mind, the application has been set up and our design language has been set up too, which means that immediately in the next lesson, we'll be able to start working on our first screen. So I'll go ahead and clean this up and call this Lingua, as that's the name of the application we're developing. And now we have to commit all the changes we created so far. It seems like there's tons of files that got changed, but most of these are actually coming from this AGENTS.md folder, which are instructions for everybody following along with this video and for their agents specifically to know what's happening. We only need to install this once. And if you're wondering, should we really be pushing this over to GitHub or not? Should we be keeping it private? Well, it's always great to push the agents to GitHub as well, so that other developers and their agents working on the project also have the same context as you. We also added the initial routes, the assets, the constants, and the prompt materials. For you, you might also have the full prompts folder here as well. This is just the setup. So open up github.com/new and create a new project. I'll call this React Native Lingua, and then create a repository. We can use the terminal to follow a couple of these lines to get the project pushed over to GitHub, or we can just ask our agent to do that for us. So I'll just open up the Claude code in a new session and tell it to push the code we have so far to a GitHub repo. And then we can, of course, paste the commands that we got right here, including our remote origin URL. It should know what it needs to do without us having to manually run these through the command line. Of course, it's going to ask you for permissions, and I'll give it access to it. You'll see that I'm using a CodeRabbit VS Code extension, so it's asking me whether I would like to start a review. Since we've just set up the project, it's not needed quite yet, but this is going to come in super handy as soon as we start developing our initial screens. And there we go. All done. Both commits, the initial one and the new one with the project setup, are now pushed to our GitHub repository. So you can reload the screen and see all the changes right here. Now, to stick with proper development practices, we're going to create and switch to a new branch called development. Again, you can ask Claude Code to do that for you, or maybe for a second, we don't have to be so lazy and we can do it ourselves by saying git checkout -b, which means to check out and create a new branch called dev. This is where we'll be doing all of our changes. And then when we implement a specific feature, we'll open up a pull request from a dev branch to the main branch so that we can review the changes, and only if it's all good, we can merge it. So with the setup complete, we are ready to start developing our first screen. In this lesson, we'll implement our first screen. If you head over to prompt material and then onboarding screen, you'll see what this screen is all about. It's a straightforward screen that has a logo at the top. It has a head text, some subtext, and then an image and a button. In this case, to keep it simple, we won't do the pagination or the sliders that you can see right here. But if you want to explore the multi-step onboarding, you can totally go ahead and do that. Doing this manually and properly centering everything and making sure it looks good on all screens would take us about, 30 minutes? Let's see how fast we can do it with AI. At this point, I assume you already downloaded the zip prompts folder and you have it here, so we can use this to fast track our prompts. We're at the lesson 03 onboarding UI right now, so go ahead and open it. We can review it together and then automatically put it into an AI agent by clicking one of these two buttons. It again starts with reading the AI agents file, and then the goal is to implement the onboarding screen as shown in the attached design exactly as is using assets from the assets folder. We sometimes have to be very specific on which assets we might want to use. Then we ask it to add a navigation link on the home route to open up the onboarding screen. Use the mascot logo image for the top logo alongside the app name. And now here, it's up to you which name you want to choose to replace Lingua. You can do whatever you prefer. In this case, I'll just use Lingua as the official app name. And do not include the pagination docs. So this is the constraint that we wanted to add. And then finally, we give it the path to the onboarding screen design. You can go ahead and copy all of this and then paste it into the chat. Make sure that it has access to this image. But an even easier way to do it is to just click any of these buttons, and you'll notice that it'll preload the MD file as the attached context. So that way, the full prompt is already here. And you can simply tell it to implement it. It'll read the prompt file to figure out what it needs to be implemented, and you can see that it's automatically reading the Agents.md, which means that it knows what it has to do. It'll explore the project structure, explore the onboarding screen image that we shared with it, so it knows what needs to develop, read all the images and the layout and everything else, and get it done, hopefully with the right layout. So let's give it a minute, pause the video, and I'll be right back. Once it figured out what it wanted to do, it implemented the onboarding screen, the home route, and registered that new screen. That includes editing the index.tsx to include a link to the onboarding. As you can see that right here, it basically added the link to open up the onboarding route. Then it edited the layout to add that new page. And finally, it implemented the onboarding page by wrapping it in a safe area view so everything fits within a single screen. It added a simple top image, a heading. It simply added the image and the logo, the hero heading, the subtitle, the mascot illustration, and finally, the call to action button to start using the app. So reload your application by just pressing the letter R, and you should be able to see a new open onboarding link on your phone. Go ahead and click it, and you'll be redirected to this page. The logo is at the top, the hero text and subheading are there. There are some chat bubbles right here, but the image isn't really visible. And finally, there's the Get Started button, which looks very nice. We're almost there, but let's take a look at the image that it was supposed to use from the assets. That's going to be the mascot welcome. This one right here. It didn't have the chat bubbles, and the onboarding screen design that we provided had them. So it figured out that it needs to do that with CSS. In this case, I would actually recommend that you try to come up with a full image, including those bubbles already, as it will be simpler. But sometimes your designer or your AI will provide you something that looks more like this. So you'll have to find your way around it. Before we fix that though, there's another thing that I noticed. In the onboarding page, you'll notice that the AI may have mixed Tailwind CSS classes, like it uses them here, with the typical style sheet styles that it uses here and that it defined below. This is way too much, and we don't need this if we're using Nativewind. And this is because the Agents.md file instructs it to use style sheet for elements like safe area view, since Tailwind CSS doesn't work reliably with some React Native components. However, the AI might have over-applied that instruction and generated the style sheet styles for other elements as well. At this point, you can either prompt it again to convert those styles back to Tailwind CSS where appropriate, or leave it as is and let CodeRabbit review the implementation, as I'm sure that it's going to flag this inconsistency. So let's fix those two one by one. You want to send only one corrective thing at a time. So first, we'll tell it to properly center the mascot image in the middle. Right now, it's off to the side, and I'll provide a screenshot of exactly how it looks. So it gets the idea of what's wrong, and just paste it. And it's likely that it implemented it properly for you right from the start. Sometimes the AI will handle something properly on my end, but not on yours, and vice versa. So when it breaks on both of our devices, that's great. I'll go ahead and show you how to fix it. When it breaks on my end, but not yours, you can be happy and just watch me fix it, or skip through a bit. But when it messes up on yours and not on mine, unfortunately, I won't be able to help you. So pause the video and apply a couple of corrective fixes until you get the right solution, and then we can move on together. And very quickly, it just centered the image. So now that our onboarding screen is looking good, I want to ask it to not use the style sheet as much. Again, if we take a look at the onboarding, you'll see that it uses a lot of manual styles using this style sheet. While it is necessary for the safe area view, it's definitely not necessary for all of these other elements. So I'll specify that the agents.md file only specifies to use the style sheet for components where Tailwind CSS or Nativewind class names don't work natively, which is the case for the safe area view, but not for text, images, and all of the other components. For those, still use the class name Nativewind syntax, fix the onboarding screen to do it properly. And after a minute, it updated it. So now if we head back over into the onboarding screen, you can see that now the styles only include a shadow and everything else is done through class names. This looks good. We have a clickable button at the bottom, which means that our onboarding screen had been implemented. So what we'll do for every new feature that we implement is review it before we merge it over to the main branch. So open up your terminal, run git add dot git commit -m, implement the onboarding screen, and then git push. Of course, since we created a new branch, you'll have to set upstream to our remote origin, so we push it over there. Here, you'll see that our dev branch had recent pushes 2 seconds ago, so let's go ahead and compare them to the main branch and open up a pull request. You'll see that on my end, CodeRabbit will automatically start reviewing the changes. That's because I use it for all of my projects. If it didn't yet show up right here with some random quotes for you, let me show you how to set it up. You can click the CodeRabbit link down in the description to set it up. We'll use CodeRabbit for our AI-powered reviews. And trust me, reviewing your code is even more important when you're generating it with AI in the first place. I mean, they're the strongest player right now in the AI code review industry, with over 3 million repos checked, and you can go ahead and watch this video to see why the teams prefer them. But one of the biggest points is going to be that the CEO and founder of NVIDIA, a huge organization, said that they're using CodeRabbit all over NVIDIA. And if it's good for such a huge corporation, trust me, it's going to be good for our own projects as well. So go ahead and create your account, then click Add Repositories, and give it access to all the repos. You should be able to see your new repo right here. That's going to be React Native Lingua. And that means that it's already tracking all the changes. So if you come back, you might need to do another push on the dev branch to be able to see the changes, or it's going to be there on your next PR. For me, it's already there, and it first greets us with a summary of what we did within that PR, which is super useful if you're working in a team and somebody else needs to review it. The summary is great so they can see what happened at a glance. In this case, we're introducing an onboarding screen with a branded experience featuring a mascot character, multilingual welcome messages, and a Get Started button. Then we get a walkthrough of exactly what happened across different files. This PR review was super simple, as we just modified a couple of files, but trust me, as we continue later through the build, the reviews are going to get much more detailed. In this case, there's just one actionable comment posted, and it's a major issue as well as a quick win, telling us that the call to action button, this one, this Get Started one, is not functional. It doesn't lead to anywhere. So the suggested fix is to basically implement a function that tells us where it needs to lead. And I'll mark this as resolved, as it'll be leading to the auth page, which we're going to develop in the next lesson. So go ahead and merge this PR and get back to your code base so we can start implementing the auth next. In this lesson, we'll implement the Auth Screen's UI. No logic for now, just the UI, and that UI will look like it does right here in the prompt material under the Auth Screen. So we need a text, a subtext, a nice illustration, as well as input fields and social login buttons. And then we'll tell AI to reuse it and create similar screens for sign-in too. So head over into prompts and head over to authentication UI. The goal is to implement the sign-up screen exactly as is shown in the attached design. Then create a matching sign-in screen using the same layout and visual style, but with sign-in copy and no password field. Both screens should use the email and social auth UI only. And then we are updating the onboarding, so pressing the Get Started button, which CodeRabbit flagged, navigates to the sign up screen. And when the main sign up or sign in button is pressed, we want to show a verification modal saying that the user has received an email and should enter the verification code. The code should be 6 digits, it should use the number pad, and we want to keep the modal above the keyboard and automatically navigate to the home route when the last digit is entered. And then we also give it the Auth Screen layout. So go ahead and open up your agent in a new window and tell it to implement it. Of course, make sure that you're providing the full Markdown file or that you actually paste the contents of the Markdown within the chat itself. And then press enter. Pause the video, give it about a minute, and I'll be right back. This time, it actually took it about 2 minutes to understand the task, and then about a minute more to get the full picture of everything that we wanted to implement. Then it came up with a list of different to-dos, and it started implementing them one by one. By first adding the auth layout, which is going to be the parent layout of both of these sign up and sign in pages, and then the additional components such as the verification modal and the social buttons, which is going to reuse across those 2 pages. And now it's going to go through the process of developing it. And very quickly, we get a full summary of what's changed. We even get the info on what we need to do to test it out. So it says right here, run the app. We already are running it. So I'm going to go back and I will reload the application by pressing the letter R. Then open up the onboarding, click Get Started, and that'll bring us to this beautiful auth page. First, we are on the Create Account page, but you can also switch over to the Login page by pressing the link on the bottom. And you can keep switching between those 2 pages right here. The Create Your Account page is a bit longer, so it doesn't fit within a single view, but it's still nicely scrollable, so we can see the full contents. Still, we can remove some social options in case we want to make it fit within a single screen. And most importantly, when you click on a specific input, the keyboard opens up, and since the sign up button is right here, everything is still visible. So you can nicely enter your email and password, and then sign up or sign in. And when you click it, the modal pops up, allowing you to enter your 6-digit code that you received via email. I mean, you haven't received it yet, but you will soon, as soon as we implement the logic for the authentication. So the fact that we were able to develop the UI of these 2 pages so quickly, in literally a couple of minutes, is absolutely crazy. If you want, you can check out these components in detail, or as usual, just ask it to explain each generated file, or maybe a specific file that you're a bit confused about, such as the layout in detail, including the reasoning, architectural choices, and design decisions. So if you take a look at the layout, it is basically just a parent layout, which hides the header from all of the pages within the layout. In this case, that's going to be the sign in and sign up pages. So the explanation is going to be simple. We have the root layout, but specifically here, we're wondering about the auth layout, which essentially forms the group for the auth pages. And it's short by design. First, we have to ask ourselves, why does this auth group exist in the first place? That's because Expo Router uses route groups to locally organize screens without affecting the URL. That means that as you navigate over to it, they're going to be contained within auth, and these parentheses are dropped from the URL. And this is purely organizational. So you can see how you can use AI for these beautiful explanations of what it implemented. So now that our UI is done, in the next lesson, we'll implement the logic for the authentication. But first, let's review this auth UI. Instead of making a pull request to review all the changes within GitHub, CodeRabbit also has its own extension. Once you install it and authenticate, it'll take a look at the files that you modified, see that they're on the dev branch, and allow you to review them directly within your code editor without ever leaving it. So I'll start the review, give it about a minute, and then we'll go through the potential changes that we need to implement to make our code more scalable and less error-prone. Once the review is finished, the CodeRabbit will have added comments directly to our code. In this case, there's just one comment under our social button.tsx component that says to convert to Nativewind styling per project guidelines. So I love this. It actually took a look at the project guidelines and saw that the social buttons uses the style sheet type of styling and not class names. The component uses style sheet create for elements that support Nativewind class name. As per coding guidelines, style sheet should only be used for specific components like safe area view, text input, modal, and so on. So the fix for this is super simple. You can either do it manually or you can click the Fix with AI button, which will trigger a conversation with the chat with this pre-filled message coming from CodeRabbit. It'll review it, check it, figure out what the project guidelines are talking about, and it'll completely remove this style sheet and instead replace it with just a couple of class names, which makes it more readable and more consistent with the general project styling. So I'll go ahead and keep those changes and then push this over to GitHub by saying git add dot git commit -m implement auth UI. Perfect. In the next lesson, let's focus on auth implementation. In this lesson, we'll make our auth UI fully functional with Clerk. So make sure that you've already created your Clerk account by clicking the link down in the description and heading over to the dashboard. Then also make sure that you have a new application created called JSM Lingua, or the name of your application. And then you can choose different social providers. In the UI, we have Google, Facebook, and Apple, but I think just email and Google are going to be fine. We can later on remove these buttons from the UI. So click Create Application. After creation, we can follow the steps to set Clerk up with Expo. So select Expo right here. And then if you scroll below, you'll see your Clerk API keys, which you can copy. Back within the application, create a new file right here in the root of the application called .env and paste this Clerk key right in. Now, there are two ways in which we can set this up using AI. One is through agent skills, where you simply download and set up Clerk skills like we did for Expo a couple of lessons ago. And then at all times when working with Clerk, your agent will know exactly what has to happen. So go ahead and copy this installation command by searching for Clerk skills, open up your empty terminal, and run npx skills add Clerk skills if you don't already have them. It'll ask you which Clerk features you want to install. In this case, go with core Clerk features, as well as Clerk webhooks. I think this one is going to be useful as well for syncing the real-time data. There's also the Clerk Expo patterns, which is going to come in super handy, and it'll tell your agent as it's specific to what we're doing. Then press enter, select your agent, do it on the project scope, and install it through Symlink. Good, that's it. And what I love about Clerk is if you head over to their docs, specifically under the Expo SDK Quick Start, you'll be able to copy the full page as Markdown. Before you click copy, switch over to JavaScript. We'll go with that option as we want to have custom UI layout for the auth. If you go with native components, you'll automatically get Clerk's pre-built components, and then you'll be able to style them a bit. So switch over to JavaScript, copy the Markdown, head back over to your VS Code, specifically within prompts, and we're working on the Clerk implementation right now. At the end, you can paste the latest Clerk documentation that you just copied. But let's read through the first part of the prompt. Study the existing auth screens and current mocked auth flow, and then replace the mock behavior with the real JavaScript native sign-in Clerk authentication by following the Clerk documentation provided below. Keep the existing UI and navigation flow intact. Implement email-based sign-in, sign-up, social auth where supported, and verification code handling through Clerk. After successful verification and authentication, navigate to the home route. If not authenticated, show the onboarding route. Do not change the screen design, and if you have any questions, ask me before implementing it. Open up the agentic chat and tell it to implement it. This one will surely take a bit longer, so let's give it some time, pause the video, maybe take a bit of a walk, or look at the distance through the window to clear up your eyes a bit. It's good for your eyesight. And then come back. And while it's still going, as I thought, this one took much longer than before because this is the first real implementation logic task. It took about 380 seconds just to think about everything, then 80 more seconds to get a complete picture. And now it's going to implement everything from installing Clerk and Expo Secure Store to wrapping the app with the Clerk provider in the layout, adding auth guards, protecting the auth routes and redirecting to the homepage if already signed in, replacing the mock sign-in email with OTP, replacing the mock sign-up with email, password, and OTP verification, updating the verification modal, and then finally wiring it all up through Expo Go, and then adding Expo Secure Store with Clerk Expo plugins to the app JSON. It's interesting how the actual process, even for it, understanding of what we wanted it to do, took longer than it takes implementing those tasks one by one. And I think that's very important. You no longer have to write everything manually, because it's not the lines of code that matter. It's about the architecture that implements the features that at the end of the day solve the business goals or solve the needs of your users. So let's give it a moment more to finish, and then we'll go through the full implementation together. And after a few more minutes, the authentication implementation is now complete. Here's what's changed. First, the app layout. It wrapped it with a Clerk provider plus the token cache from Clerk Expo Token Cache. And you can see that change right here. It is nothing more than just wrapping the stack with a Clerk provider. Then, within our app index, it added a guard so that if we're not signed in, it's going to redirect us back to the onboarding. Finally, the auth layout redirects the authenticated users away from the auth screens back to the homepage. The signup now uses real Clerk implementation through signup.password, verification sent over to the email, verifying that code, and then finally finalizing it. Same thing for the sign in through the email OTP. And the verification modal is now fully functional. Let's test it out. I'll reload the application within the terminal. And since this was a larger change, I might even stop the server entirely and then rerun npx expo start, and then press the letter R. Let's go from the onboarding to the auth screen, where we can first try to sign in through email. So I'll enter my contact@jsmastery.pro email right here. And let's do the same thing for the password and click sign up. And you'll notice that we have our error messages and warnings being displayed right as you type. The password must have 8 characters, but even if you enter 8 characters and you try to do it with a simple password, it'll tell you that this one has been found in an online data breach. So instead, let's go with something a bit more complex and click sign up. It'll create your account and then send you an email. Of course, you could open that email on your phone, but I opened it right here on my computer, and then I'll type it in, 692.117, and it logs us in. This means that the authentication is fully working. Let's try to sign out as well, which brings us back to the onboarding, and then try to sign in with the account you just created. You'll have to enter your email, that's gonna be the same one, and click send code. In this case, you don't even need your password. Rather, you'll just get the OTP within the email. So I'll type the one that I got, and we're in. Now let's sign out, and let's try to create an account using Google. If you do that, you'll notice that on my end at least, I get an uncaught promise. Clerk Expo Auth Session and Expo Web Browser are required for SSO. Install them. What we'll do next is I'll open up the terminal, and I'll simply copy this error message. Then open up the active Claude window where we were working on, and this is a situation where it makes sense to stay within the same chat. And then I'll say, the email sign up and sign in work, but when I try to create an account or continue with Google, this is the error that I get. And then we can simply paste the error right in and press enter. This took less than 10 seconds. It just installed the Expo Auth session, as the SSO flow requires it alongside the Expo web browser, which was already there. So let's restart our session by stopping the server and then running it one more time. And then once we're there, you can head over to the Auth screen and click Continue with Google. This time, it says Expo wants to use accounts.google.com to sign in, so click Continue. And as with all the applications, it nicely opens up a new browser window asking you to authenticate with your already logged in account. So go ahead and choose it and click continue. And that's it. Within a couple of clicks, you're signed into your application. Note that I used a different Google email from the one that I used with email and password signup. So if you head over to your Clerk dashboard under your application overview, you should be able to see two new signups. We have JavaScript Mastery with all of its metadata picked up directly from Google, and the other one through the email auth. Now, our application does include two additional signup methods, which you can remove if you want to. But just to show you how easy it is to add additional signup methods with Clerk, you simply have to head over into SSO connections, add connection for all users, and now we can include Facebook. Just go ahead and enable it, as well as adding Apple, which is going to be amazing on iOS devices. Once you do that, you can just click Continue with Apple, which is once again going to pull a new window, allowing you to sign in directly through your Apple device. I mean, how amazing this is. It even uses Face ID to log you in. So now back under users, since I used the same email right here, check this out. The same email is now connected through two different social providers. And I think that's the thing that most people don't realize as they start implementing their own auth. Sure, with AI, you are faster in getting everything set up and allowing your users to log in. But there are so many of these little details that can break and cause serious trouble to your application and your users' data. So when working with databases, user data, billing, and authentication that connects all of it together, I choose to use the tools that I trust. And I mean, take a look at the length of this chapter on YouTube. How long did it take us to implement full authentication? That's amazing. We have many files changed right here, as we also installed some additional agent skills, and we already reviewed some of the code before. So for now, I'll proceed by just pushing the code over to GitHub and merging it, so that in the next lesson, we can focus on implementing the actual language logic. Go ahead and type git add dot, git commit -m, implement auth functionality through Clerk, and run git push. So that back within GitHub, you can just open up a pull request, get it reviewed for the second time with CodeRabbit if you want to, even though we've already done a quick check through the VS Code extension, and then merge the PR. Great job. Okay, in the previous lesson, we finished the authentication flow and integrated Clerk into the app. Now, before we move into the actual language selection screen, that's going to look something like this. We first need to set up the structure of the learning contents of the app properly. Because if you think about it, almost everything in this app depends on content. Languages, lessons, units, vocabulary, phrases, and AI teacher prompts. So instead of hard coding random things inside of different screens, we're going to organize everything into properly typed data files. This will keep the project much cleaner, and it'll also make the AI workflow significantly more consistent because the app will now have predictable data structures. And since this is an MVP, we're intentionally not using a database yet. Instead, we'll use Expo React Native Async Storage. That'll serve the data locally alongside Zustand for persistence. So things like selected languages, lesson progress, local app state, it can all stay on the device itself without needing a proper backend yet. This will also keep the project much easier to iterate on until we get to the stage where we're sure how we want our structure to look like. And that's how good developers build things. You do the whole UI and MVP the features properly with all the needed functionalities with hard-coded data first, and then integrate a database functionality and make it ready. You're learning how to build for iteration, speed, and go-to-market strategy today. So with that said, let's generate that learning content architecture for the application. Head over into your prompts, and that's going to be prompt number 6, the content system. Create the learning content system using hard-coded TypeScript data. Add types, learning, data languages, data units, and data lessons. I was very precise right here, just so both you and I have the same structure, but of course, otherwise, AI would have been able to figure out what it needs to add. We needed to define the supported languages, units, lessons, activities, vocabulary, phrases, lesson goals, and AI teacher prompts for future audio-based vision agent lessons. This has more to do with what you want your application to have, rather than which features or pieces of code we wanted to implement. And that again shows you that it's all about thinking what you want your app to do, instead of how you want to do it. So include a small, beginner-friendly sample dataset for a few languages and keep it simple, typed, and easy to extend. Whenever you have multiple languages, it is incredibly important to stick to a typed structure where you know how the data looks like, because only then you can extend it to additional languages. So let's go ahead and feed it into the AI and just tell it to implement it by making sure that it already has access to this content system MD prompt. Let's give it a minute and see what it comes up with. And there we go. This one was quick. It created different TypeScript interfaces for language codes, such as Spanish, French, Japanese, and I believe this is German. The three main entities, language, unit, and lesson, as well as the lesson building blocks. So far, it added 4 demo languages: Spanish, French, Japanese, and German, each with their code, names, native name, flag emoji, and accent colors. It also added 1 unit per language and 9 lessons in total. So let's check it out. First, we have these types. This is essentially just TypeScript, where we define how a language structure looks like. Language has a language code, which can be one of these languages, and later on, you can very easily expand it to add an additional language. Then there's different activity types, such as testing vocabulary, translations, multiple choices. The vocabulary item can be a word, it can include a translation, pronunciation, and an emoji. Phrases, activities, lessons goal. This is the core of our application, and AI makes this super easy. But of course, before this, you had to plan how you're going to structure your application and what is it going to be all about. Are you going to have different lessons, languages, units, and so on? And more of that is right here. So we start with different languages, starting with Spanish. And instead of emojis right here, I just want to replace this with real flag URLs. So I found this nice flagcdn.com where you decide on the width of the flag and then you just use the code.png to generate it. So what we can do is just very easily replace it with this URL. And it's always great to use a CDN because you can very easily make it work with all the other languages without having to add additional emojis, for example. You just have to change the code, which we already have. For now, I will hard code it 4 different times instead of the flag and use a different code. But later on, it is super simple. And I mean, it will literally take 5 seconds with AI to turn this into a function that would automatically return a flag depending on the code. So you can definitely give it a shot on your own. So that's how the languages look like. Then there are units. So in this case, we have the unit number 1 for learning Spanish. Greetings and Basics is the title. Start your Spanish journey with everyday phrases. And then it has the order and then lesson IDs attached to it. So then in another piece of data, we have the actual lessons. Lesson 1 with the title, Learning Readings. And then it has some goals and even XP rewards so that you can gamify it like Duolingo does. And there's different words in the vocabulary like hola, adios, and so on, alongside their translations and pronunciation. Pretty cool stuff, right? That is the core of the application. Now, in the next lesson, we'll extend that further to create the actual language selection screen. Okay, now that the learning content structure is ready, we can finally start connecting that data to actual screens inside of the app. And the first place where that becomes useful is the language selection flow. So that's going to be our prompt number 7, language UI. This one is referring to the prompt material 04 language selection screen. It is this one right here. And that's the entry point to the user's entire learning experience. Because once the user selects a language, that selection will later decide which lesson appears, what AI teacher context gets loaded, what content shows on the home screen, and what progress gets persisted locally. So both design and functionality And this screen sits right between authentication and the main app experience. So, how do we tell the AI what needs to happen? Implement the language selection screen UI based on the attached design, referring to the one you just saw. Then use the hard-coded languages from data languages and the existing Nativewind globals.css design utilities. Replace See All Languages with confirmation button and use the Earth image from the assets folder properly. Add a link to the home screen to navigate to the language selection screen route. Open it up with your agent in a new chat and tell it to implement it. Let's give it a minute and see how it does. And after about a minute and thinking a bit, it got all the context it needs. And it started implementing the language selection screen. It figured out that the image that we shared also includes Korean and Chinese, so it easily extended the current structure. Then it created the language selection screen and modified the home route so it actually shows this Choose a Language button. To be able to see it on the screen, you can just reload the application and click Choose a Language. And this is beautiful. We can see search languages at the top where you can start typing to get to your chosen language a bit more quickly, or you can just scroll through and select a language. Now, does it look like it does in the final version? Well, yeah, more or less it's there. It's looking good. Maybe the image is a bit cut off, at least on my end, and you can fix that with a bit of a corrective prompt, telling it to render it in its full aspect ratio. But other than that, it's perfect. So let me continue with Spanish. And once that is done, we get redirected back to the homepage because we haven't yet implemented the actual lessons. We'll do that later. But for now, the app contents, or what is soon going to be the data within the database, and the UI for choosing a language screen are now done. And that's enough to open up a new PR and get the code reviewed. So let's go ahead and push it by heading over into a new clean terminal, running git add dot, git commit -m, implement app contents, or you can also call this app business logic, or in this case, the learning logic, as well as the language selection UI, and run git push. Then back on GitHub, you can compare the changes between the dev branch and the main branch, and wait for CodeRabbit to share its thoughts on some potential bugs that the code might have. So let's give it a minute and see what it has to say. And we got back 3 actionable comments. One is critical and is also a quick win, and it is that the selected language is never committed because the continue button right now doesn't do anything different than just clicking back. This is actually okay because that's the next feature that we're going to focus on. Then there's the language select, where it suggests that we move these static, non-exempt styles from style sheet to Nativewind classes. Again, we want to make sure that our codebase is more consistent. So you can copy this prompt, head back over into your app, and open up your agent, and then simply paste it, specifying to remove the style sheet references and move it into Nativewind. And while the AI agent is implementing that, we can head over to the last one, a major issue, where we shouldn't expose unsupported languages in the selectable list yet. Like in this case, we have Korean and Chinese. So instead, those should be commented out for now until we implement the full logic for them. So I'll head back over into languages and just comment out Chinese as well as Korean because we don't yet have the support within the lessons for them. And let's wait for the agent to turn these style sheet styles into class name styles. Once that is done, we'll be able to make another push and then merge the changes with the correct improvements added. Looks like it'll do it as I'm speaking. Remove all of those styles. And as it is finishing, I will open up the terminal and run git add dot just as it finishes. There we go. Git commit -m, implement CodeRabbit suggested fixes, and run git push. With those new changes being recognized right away, we can merge this PR and move on to adding the actual functionalities. We'll do that through managing the state using Zustand and async storage. So let's work on that next. At this point, the UI for the language selection flow is ready, but the app still doesn't actually remember the user selection. So if the app reloads for whatever reason, and by the way, you can get to this screen by shaking your device, literally, and then pressing the reload button, all of the state will be lost. And that's exactly where Zustand and async storage come in, to persist data across the app. So what is Zustand? Well, Zustand is a small state management library. You can think of it as a place to keep app state that many components need to share, without passing props everywhere or writing Redux-style boilerplate. And async storage is a local, persistent key value storage, which saves small pieces of data on the device like settings, cached app state, flags, or any non-sensitive session data. So the idea here is simple. Zustand manages the app state in memory, and async storage persists that state locally on the device. So when you open up the app again after closing, the values still stay there. Many companies like WhatsApp make use of async storage to store majority of data locally on your device, and you're learning how to do just that today. So once the user selects a specific language, we can then store it locally and then restore it automatically whenever the app opens again. For this project, this makes a lot of sense because we're intentionally not using a database yet. We want the app to stay simple, local first, and easy to learn and iterate on. So let's connect the language selection flow to the actual persisted app state. Back within our application, go ahead and open up a new prompt. This is going to be 08 Zustand.md. The goal here is to integrate the language selection state. We want to store the selected language using Zustand with the modern React Native async storage package. If an authenticated user has no selected language, simply route them to the language selection screen. And then only after selecting a language should they access the home route. Preserve the existing UI exactly. And we also want to add a button on the home screen route to clear the async storage for testing the language selection functionality. Makes sense, right? So go ahead and open up a new agentic session and simply tell it to implement it. We'll give it a minute as usual and see what it comes up with. This task was super simple. It immediately understood what it needs to do, checked if there's a store directory, and then once it figured out that the store doesn't exist yet, it started creating one right here with Zustand and async storage persistence. Then it's going to update the layout to include the language select screen in the stack, update it to save the selected language, and finally, update the homepage to redirect to a language selection screen if no language has been chosen, alongside adding a clear storage button. So it went through all of the steps, no errors, implemented a single new file, which is the language store. So let's go through that store together. As you can see right here, we're using the async storage from the React Native async storage package, as well as create coming from Zustand. And this store is nothing more than just an instance of the store create coming from Zustand. We pass in the state that we want to persist, and then it's going to include the selected language, the setter function for the selected language, and the ability to clear the language. That's it. And we're storing all of this in JSON storage right here under name language storage. So what do you say that we go ahead and give it a shot? I will reload our application, and it looks like there's going to be a problem as there's a syntax error happening within Zustand middleware package. So in situations like these, I would go ahead and copy the entire error and then paste it into the chat by telling it, analyze this error and fix what's causing it. It looks like it figured out what's happening immediately. The unstable transform import meta was not present in the Babel config because Babel config didn't exist yet. So it needed to create one to enable this polyfill. That's because Zustand's DevTools middleware uses the import meta, which React Native's JS engine doesn't support. So to test it out, we have to restart the bundler with a clear flag to clear the cache and start it properly. So go ahead and run npx expose start with a -- clear flag, and then press the letter R to reload the app. As soon as you do that, you'll be able to see your homepage. Now you can select the language and click continue. And at this point, the language had been chosen. You can go ahead and select another one and it would be good to actually display the chosen language on the homepage so that we know that something was selected. So I'll quickly tell it to do that. Display the chosen language on the homepage. That way we'll know that something is actually stored and persisted throughout the app state. And once you have the state, that is super simple. The only thing it needs to do is fetch the language and display it from the state. And there we go. Currently, French is selected. I like how the AI here actually gave us the full English name of the language, the native language name, as well as the flag. So now if you go ahead and select a different language, like let's say Japanese, you can see that state is being persisted across the application. And you can also use this clear command to clear the state and automatically select another one. So this is working incredibly well. It was quite a small feature, so we won't go ahead and review the changes quite yet. Rather, in the next lesson, we'll focus on implementing the bottom tab navigation, which will allow us to move across different screens soon enough, all with the persisted language state. So let's do that next. Okay, so now that the language selection flow is working properly, the next thing we need to focus on is the navigation for the actual app experience. Because up until now, we've been mostly building isolated screens, but real mobile apps revolve around a primary navigation structure. And in our case, that's going to be a bottom tab layout. If you head over to the prompt materials, you'll see the tab navigation right here at the bottom. We need to have something that says like home, learn, the AI teacher, chat, and profile. And you'll find this bottom navigation on almost every single mobile app because it's easier to press something at the bottom of the screen with your thumb or your pointer finger rather than scroll all the way to the top. This is where you want to display the information, and at the bottom is where you want to have your navigation options. So while we're not going to implement the whole homepage UI yet, we want to start with implementing just the navigation structure, the routing, tab integrations, and even some animated tab behavior. Remember, we want our tasks to only be about one thing. And navigation itself is already a complete feature on its own. If we try combining navigation, animations, screen UI, and everything else inside one prompt, well, outputs usually become less predictable and harder to debug. So instead, we isolate the navigation system first, make sure the transitions and interactions feel correct, and then later plug the actual screens into the structure. So with that said, let's implement the tab navigation. Head over right here into prompts and go over to the bottom tab navigation. The goal here is to implement only the bottom tab navigation based on the attached design. Create the tab routes for home, learn, AI teacher, chat, and profile with a simple placeholder screens for now. Then we also want to build a custom tab bar with an active circular indicator for the selected tab. The active tab should appear inside a colored circle showing only the icon without label, while inactive tabs should show both the icon and the label. We also want to add smooth animated transitions for the active circle moving between the tabs. And here's a constraint: do not implement the home screen UI yet. We'll do that soon. So go ahead and open up your agent and tell it to implement this feature that we just passed into it through Markdown. This task that we gave it includes more stuff that you might think about. So before writing a single line of code, even AI ended up thinking about it for 3 minutes. And then it came up with a complete plan. So first, it needs to create the actual tab bar with those animated sliding circles. Then it has to put it within the layout so we can see it on all the screens, create placeholder screens for all 5 tabs, include all of those within the tabs layout, and then redirect to the tabs if needed. So once it figured it out, it's going to be pretty simple for it to implement all of those screens. And check this out. It created all of these files, and now our app looks much different from what it used to look like. It already feels like a complete application. Where currently we're taking a look at the homepage, there's a little house icon at the bottom. Then there's the Learn section, which opens up the Learn screen, and you can see how it nicely animates to it. Same thing with the AI teacher, chat, and profile. At this point, we have a real fully functional React Native application with 5 different screens. But the animation, even though it looks cool and springy, is not perfect yet. I think we can do better. So let's tell it something like, fix the tab navigation. Make it linear, smooth, active tab navigation instead of using that bouncy spring animation. And let's see what it does. With AI, you're really gonna know what you're after because it can really do anything. But it's up to you whether you can actually give it the proper tasks. So now design and architecture and actual planning and thinking about the ideas you want to implement matters more than ever. Okay, so it replaced it. Now, if you head over here, you can see how much faster and more natural this feels. Love it. This is now amazing. Now, at least on my end, I'm noticing some extra white space below the navbar. So let me quickly ask it to remove it. There's a little blank empty white space at the bottom of the navbar. Can you push it down so there's no space left? And once again, notice how I'm continuing the chat in the same context window and not creating a new one because this is related to the task that we're currently working on. And there we go. Now it pushed it to the bottom. But on my actual screen, it doesn't look that good, to be honest. It's too out there and the left corner of the icon is touching the left corner of my screen. So I actually don't like it. In those situations, when you want to revert back, you can simply hover over the message you sent and then rewind the code to this point in the application. That's gonna push it back up, which I actually figured out I prefer. So with this in mind, we implemented the async storage and XCode as well as the bottom navigation. I think this is enough for us to push it over to GitHub and get it reviewed. So you know the deal, run git add dot, git commit -m, implement state management, and bottom navigation, and run git push. Again, you can immediately review those changes directly through your CodeRabbit VS Code extension. But in this case, I'll go ahead and open up a PR directly on the GitHub interface so that we can give CodeRabbit some time to review it here. Oh, and you know what? While it's reviewing it, we can head over to the next lesson and implement the full homepage UI. So it has more stuff to review and all of it is still kind of related. So let's implement the homepage and then we'll review it all together in the next lesson. At this point, the app finally has a proper navigation structure. And now we can start implementing the actual experience that users see after opening the app. And naturally, the first screen we should build is the home screen. So unlike previous navigation lessons where we focused mostly on structure and routing, this lesson is more about connecting real app data to the UI. So we'll combine Clerk user data, selected language and state from XCode and async storage, as well as lesson data from our data files, all into a single screen. So go ahead and open the prompt number 10, Home UI. The goal here is to implement the home screen UI exactly as shown in the attached design with spacing structure and such neatly and exactly done as according to the design that we share. This design is right here, home and tab navigation. So here you can see that we'll be connecting different pieces of data. The language that the user has selected to learn, their name, the streak, the daily goal, as well as some additional lessons that they can learn about. So head back over into the home UI. And then the next goal is to, as I said, display the logged in user information from Clerk and the selected language from XCode and async storage. Then use the learning data from data to show the current lesson, progress, and today's plan. We also want to use the assets from the assets folder placed via the centralized image support. If any image is missing, use a suitable placeholder from Unsplash or Pixum. That's it. Let's go ahead and see how well our agent can handle the UI. So I'll say implement it. And let's give it some time, as here it really has to understand what our application currently has, how it can pull all those different pieces of data, and then finally build the UI and hook it all in. And fast forward a couple of minutes, it thought about it, it implemented it, and take a look at your phone. We have a beautiful language learning application home screen right on your phone that you developed with the help of AI. It's also keeping track of the language that you selected. In my case, it was French. So it says, hello, JavaScript. That's my first name in French. For you, it's going to say something else. And then you can actually start learning the first unit and the first lesson in the French language. This is just wonderful. And check this out. at one point, it also auto-fixed itself. I'm pretty sure this is because of some rules within our agents.md. It was able to find that the import should be add clerk expo and not add clerk/clerk expo. So it fixed it, checked for type errors, and after it was done, everything was working. So I think having this check for type errors thing in your agents.md is always a super useful addition to any prompt. So with that in mind, the implementation is now complete. It built a new store, learning store, with persisted Zastand store tracking for XP, daily goals, and streak. Exposes the add XP and complete lessons so that we can call them from the homepage or from additional screens. And then it updated the full home screen to match the design. There's a header at the top. There's a localized greeting with the first name from Clerk, streak, fire image, count, and bell icon, the daily goal card right at the top, the continue learning card, and then the today's plan, as well as next up cards. For now, just to make sure that everything fits within a single screen, I'll tell it to remove the next up card. I don't think we need it at this stage of the application. Later on, maybe we decide to bring it back or put it within some other screen. So let's give it a second to remove it from the homepage. And now everything fits neatly within a single screen. Beautiful. You can also see that it again styled things using the style sheet and not using the class names. And we already know that CodeRabbit will flag this, which is amazing. So I'll tell it to fix it right away. Wherever you used the style sheet to style the specific components that support Tailwind and Nativewind class names, remove the style sheet styles and turn it into class name styles. And let's see how it does. And after about 3 minutes, it went through all the components within the application and it converted the styles into class names for components like view, text, image, and static touchable opacity. But it kept them intentionally on a safe area views. And you can see the application didn't really change. Everything is still working as it did before, which means that our homepage UI is now done. So we can push it by running git add dot, git commit -m, implement home screen UI, and then run git push. This new push will automatically be recognized by GitHub and therefore by CodeRabbit 2, which is going to run another check for this new commit on the same PR. And while it's doing that, we can go through the review that it provided so far. This is an interesting one. Here, we have to gate the redirect logic until the persisted store hydration finishes. So line 23 can run before the Zastand async storage persistence hydrates, causing incorrect redirects to the language select screen. This is happening on cold start for already configured users. The app currently only waits for Clerk authentication to load, but not for the language store to rehydrate from storage. So use language store persist has hydrated as the hydration lifecycle callback to delay the redirect check until both Clerk and the language store are ready. This is an amazing suggestion. So I'll immediately go ahead and copy all of these lines, head back to this screen where we have the activity indicator. That's going to be just the app index. And right here, we need to replace everything from the top constant to the if statement. Or we can ask our agent to do that for us. So I'll open up a new agentic window with this file loaded in, and I'll simply paste what we just copied over from CodeRabbit. It'll go through it and properly verify that we're hydrating the stored data before checking its variables. And while the agent is doing that, we can immediately navigate over to the second suggestion that we have, which is a critical one, where we have to fix the stale tab width after the orientation changes. Oh, that's a major one. Some applications allow you to change the orientation of your screen. Currently, we don't. So if you try to move over your screen to horizontal view, it's going to remain. And that's because most apps are mostly usable in vertical mode. So since we don't plan on changing the width after the app is loaded, this is okay. And then this one is about adding some semantics, so it's easier for screen readers and assistive technology to understand what's happening. Always a great thing to add. And you can see that now our agent also implemented this language hydrated, and it added it to the depths so that we're properly displaying the screen only when we're sure we have the real data. And the additional review came in from the homepage UI, telling us to add a guard against division by 0. If daily goal is ever 0, XP progress becomes not a number, which would cause rendering issues in the progress bar width. Yep, that's definitely true. So it's just telling us to replace it with a single line, which is exactly what I'll do. That's going to be back within the tabs index, and we have that part right here, XP progress. Currently, it could be a nan. If it is not a number, it just brings it back to 0 as well. So that's good. With that in mind, we can push those changes by saying git add dot, git commit -m, implement, code rabbit, suggested fixes, and run git push. If you get back, GitHub will automatically recognize the changes, so you can go ahead and merge them into the main branch. And with that in mind, our app is getting more and more finalized with every new lesson. And at this point, I believe it reached a stage where we can start thinking more about users and how they're planning on using the app in ways which maybe we didn't assume they would, so we can cater more to their preferences. I'll teach you how to do that for this app and every other app in the next lesson. Okay, now that we've got the authentication working, where users can sign up, sign in, and navigate to this beautiful homepage UI that we just developed, that's great. But right now, we have zero visibility into what they actually do once they're on the inside. Which screens do they visit the most? Do they tap on the continue lesson? Or do they check off the today's tasks? Maybe they check the notifications first, or just head over to their profile and delete it immediately and never come back. Without analytics, you're just guessing. So that's why I'll teach you how to implement PostHog to be able to track all of this and more. Click the PostHog link down in the description and get started for free. Choose your region and then sign up. Once you're in, you can create a new project and give it a name of JSM, Lingua, or whatever the name of your app you chose. From there, you can just go over to the onboarding flow. Now, while most dev tools have their CLIs and MCPs, PostHog took what I believe is a revolutionary approach to setting up a specific tool and making it work instantly within your project. They call it the PostHog AI Wizard, and essentially, it is just a single command that you need to copy, paste into your terminal, and it'll automatically detect your framework, install the SDK, and then set up the event capture. So head back over to your application, expand your terminal, and run npx-y add posthog/wizard add latest. And if needed, you can also select your region. It'll open it up right here. Then this screen will pop up. We'll use AI to analyze your project and complete work, essentially doing 2 hours of work in about 8 minutes. It figured out the directory, the framework we're using, as well as the workflow that it's going to put into place. So you just have to press enter to continue. And now it'll ask you to authenticate using your browser. After you log in, you can return to your terminal. The wizard is already working in your project. PostHog's CLI wizard will read your codebase and do the setup for you. So instead of manually installing the packages, creating providers, and writing event calls, the wizard handles it all. The first thing that it's doing is analyzing the project. And on the left side, you can learn some of the things about PostHog while you're waiting. If you're looking at the screen, that is. The point of this is that you can now walk away and let PostHog implement the event capture and more directly within your specific project. This changing learn part on the left side while the screen is loading is reminding me of older video games where there were loading screens and then they were showing you some kind of tips and tricks to pass the time faster. Okay, but now we get a bit more info on what the wizard is actually doing. It is generating the event tracking plan and creating PostHog events.json file. Then it'll proceed installing the PostHog packages and setting up the environment variables. Finally, it'll create the PostHog config files, wrap the app with the PostHog provider, and then add the screen tracking within the app layout. Finally, it'll insert the event tracking code into the app screens. So this means that it doesn't just set it up, and that's what's different from other CLIs. The wizard will, sure, set it up, but then it'll also analyze your project up to this point. Ours isn't yet fully completed, but later on it will be, and immediately implement event tracking where it thinks you might want it. And so far, it always did the exact same thing that I wanted. Of course, as we finish our application, we can continue adding additional event tracking either manually or through the PostHog MCP. Finally, it'll add user identification on sign in and sign up so that you can track the user's full flow. Maybe the users that select the French language end up having a lower lesson completion than those that have Spanish, which is valuable data to have so you can tweak it. Maybe the lessons in French are not as engaging as lessons in Spanish, or maybe it's something else. Either way, by having the data, you'll understand exactly what's happening within your application. And while the app is being set up, I want to show you how you'll be able to make sense of the data that you're now adding the tracking for within your application. As soon as you visit the home, the central part of what you see right here is a little chat window that gives you access to your dashboards. So obviously, you can create different dashboards and then within those dashboards, add different insights, such as tracking the daily active users or weekly active users, the retention within the application, where they're coming from, and how many screens do they visit in a single app use. And while this is useful, what I love even more is the chat. Through this little chat window, you can ask PostHog anything you want to know about your application. Then it'll intelligently figure out which insights and metrics and data points it needs to tackle. It needs to connect to give you back a full response. I'll be a bit generic here and see what it comes up with. Give me the most important data points about this application. What's happening with the users, which screens are being most visited, and anything else you think might be useful. Sure, this is super vague, and I'm doing this on a little demo project that I'm working on. But still, even with very limited data and the generic prompt, I want to show you what PostHog is capable of so you get an idea of what it can do for you when you implement proper metrics. It first comes up with a plan to explore available events and properties, then search for existing insights and dashboards, create key insights about users, stop screens, and more, and then finally compile everything into a report. And it already figured out the 7 existing insights that could be relevant for this report. So the main part that I love about what PostHog does here is that it doesn't just spit it out in a text format. Rather, it creates actual dashboard-like insights where you can visualize the data. This is what I mean. Like in real time, it came up with the numbers that it believes would be useful to me based on what I asked it. This is the number of daily active users, obviously dropping. Then this is the app usage, like how many people are using the app, which screens are they checking out, and then the retention. Are they visiting through desktop or mobile? And it'll compile it all into a report. There we go, combining the text with some trends with the actual data coming from the dashboard. So here we can look at all the data pieces, what's happening, and so on. And then finally, it'll analyze it based off of my request and tell us what is happening. Daily active users are declining. Retention is low. We aren't identifying the users, and that's happening because of some gaps in instrumentation. So just imagine how much more powerful this would be on a real actual project and not a little demo, where we've set up tracking and metrics for all the key events with proper user identification. And while we're going through it, the wizard finished its job, and it's asking us whether we want to install the MCP. The MCP will let your AI coding tools like Claude query your PostHog data directly, so you can ask them which screen has the highest drop-off, answered from your actual analytics. And then you can ask your agent to fix it to improve those points. So it makes everything work together nicely. I'll go ahead and install it, select the editors that we're using, and press enter. You can also select which features to enable. I'll enable all, and that's it. The MCP server has been installed. And as I told you, the wizard automatically figured out which events we want to track. So in this case, it's tracking the onboarding get started tapped button, the sign up submitted and completed, whether they do it through the Google authentication or Apple maybe, which language gets selected, and when they click continue learning or navigate to a different tab. Well, these are all the events that we can track for now. And later on, as we continue adding more features, we can track more events. So that's it. Let's take a look at the files that got changed. Some are the skills for Claude, so don't be scared, there aren't that many changes. But some is the actual PostHog implementation. Like right here in the main layout, where we wrap everything with a PostHog provider, And there's even the ability to capture the screens, including the screen name and property. So if you want to, you can turn that to true. Then within language select, the only thing you have to do to track which language they select is add a test ID so it knows what we're tracking the data for. And then finally, call posthog.capture language selected, and then the language code that they selected. That's it. And we're doing that on sign up and sign in as well, where we connect the currently logged in user and identify them through a PostHog profile. So what do you say that we give it a shot? Make sure that your application is running. What I'll do is I'll stop the server and then rerun it again with a clear flag. And then back within the app, you can try to press the continue button or navigate to some different routes until you see installation complete, which means that it successfully captured an event. So click next. I'll keep all of these on. The auto capture frontend interactions that works within React Native automatically captures the frontend interactions like clicks, submits, and more. And then you can further fine-tune what you capture directly in your code snippet. We enable heat maps to see where the people are hovering, clicking, and so on. And then also the web vitals. Session replays are also super useful because from just the clicks, sometimes it's not fully clear how users interact with the application. So if there are some UI or UX issues, you'll be able to spot them through session replays. We'll skip connecting the data sources and skip inviting the teammates. And that's it. You can now immediately create some insights, such as trends, funnels, retention, paths, stickiness, life cycles, and more. But let me just use AI to create insights using natural language. So far, we're not tracking a lot of data. You can see that we have some inputs from user interactions on the front-end side, such as when we clicked buttons, when we visited a specific screen like onboarding, then moved over to sign up, sign in, and finally, we were at the home screen. And there's even more activity. We'll be able to create insights and dashboards that allow us to make smarter decisions on where we're going to take the further development of the app. And that's it. PostHog has been set up. Let's go ahead and run git add dot, git commit -m, and say implement PostHog. And in this case, let's trigger CodeRabbit's automatic review. We'll ask it to review the changes across all 23 modified files. And in a couple of minutes, the review is back. There are 6 total issues, 2 across the sign in and sign up pages, and 1 in SkillMD, and 1 in the environment variables. Let's see what that is all about. Oh, it looks like our env is getting tracked by GitHub. Is that really the case? Back within our repo, it looks like our env really is there, which is obviously a huge mistake. And I'm very glad that CodeRabbit caught this. Now, it's not just enough to delete the file from here. I mean, this is pretty easy, right? And commit it and call it a day. I won't do that for now because it'll still persist in GitHub's history. So what we need to do is run git rm cached.env and then git commit remove env from tracking. Or you can just click this button, which will ask your agent to do that for you. And while the agent is working on that one, we can check another issue right here in our SkillMD. There's a conflicting guidance, expo constants versus React Native config. This was most likely added by PostHog, where lines 42 to 45 correctly instruct to use expo constants with app config extras for expo projects, but 47 and 48 instruct to use React Native config with .env, which is bare React Native, not expo. I believe these were added by PostHog, so the fact that CodeRabbit was able to catch this inconsistency and point out to it is incredible. Let's wait until the agent removes our environment variables from history, and then we'll ask it to fix this one. There we go. It's asking us to run these commands, and it is done, but it's telling us to rotate our environment variables if someone has gotten a chance to check them out while they were up on GitHub. Since this is a demo project with demo envs, I'm fine with that for now. So now let's ask it to fix this thing right here so that our project remains consistent. And while it's working on that, let's check the issues in sign up and sign in pages. Here on SSO, when we sign up through Google or Apple, we're missing the error handling. If something goes wrong, we need to properly catch it and capture that error using PostHog. So in this case, you can see how PostHog and CodeRabbit actually work together. Or in this case, CodeRabbit is telling us how we can use PostHog to its full potential. So while we fix these two manually, for the rest of the issues, like these 4 right here, I'll go ahead and click the Fix All Issues button across both of the files and click OK. It's going to pass the full instructions to the agent. It'll then go through them and fix them one by one. So let's give it a minute and I'll be right back. And very quickly, it went through all the changes, implemented the minimal fixes, and verified each one against the current code, which makes your code more secure. And when errors do occasionally happen, we're catching them properly through PostHog. So I'll keep all the updated changes and push them over to GitHub by running git add dot git commit -m implement PostHog with code rabbit suggested fixes and run git push. And just so our next pull request review is clean and only contains the review for what we're about to do from here on in the future, I'm gonna open up a PR and merge the code we developed so far to main, because we did do a review directly in VS Code. Perfect. So with that in mind, we can start developing the UI for some other screens within our application. And now that the home screen is connected to the actual user and the learning data, the next step is to build the core experience of the app, the lesson screen. So if you head over into the files under prompt materials, you'll find the home and tab navigation, and then after it, the lesson screen. It looks something like this. Sure, it's gamified, but you get the idea. The user can at a glance see all the lesson and the associated practices for that lesson. In this screen, we will read the selected language from Zustand and async storage, load the matching lessons from the specific learning dataset, render the lesson progress dynamically, and then display the lesson-specific visuals and metadata. And this is exactly why we separated the architecture earlier instead of putting everything inside of screens directly. The lesson screen will now mostly become a rendering layer on top of the systems that we already built, all of which are within the data part of the application. So head over into the prompts. This is going to be prompt number 11, the lesson UI screen. So let's go ahead and read through it together. Implement the lesson screen exactly as is shown in the attached design. Use the selected language from Zustand and async storage, and display the matching units and lessons from the hard-coded learning data. Allow users to select or open any lesson, no locking logic for now, and if selected language has fewer than 2 lessons in the dataset, extend it by adding at least 5 more lessons to the same structure and style. Use the assets from the assets folder, and for each lesson selection, use its respective image. If any image is missing, use a suitable placeholder from Unsplash or Pixum. Each lesson card should still visually indicate the status, whether completed, in progress, and so on, based on the local state or mock data. So go ahead and open this up with your agent and simply tell it to implement it. Then we'll give it some time, as this will require fetching all the data that we already have and then displaying it on the screen. And in about a minute, here's what it implemented. First, the lessons. It added 9 new lessons, 3 for French, 3 for Japanese, and 3 for German. All of these allow for the same full structure with vocabulary testing, phrases, activities, and AI teacher prompts, which we're going to put to use very soon. It also updated the units to include those 5 lessons. It created a reusable lesson card, and finally, the full lesson screen matching the design. So let's check it out by navigating over to the lesson screen. You can see we have some kind of an image right here at the top, which represents what this unit is all about. In this case, we're going to be learning about culture, greetings, numbers, colors, and more. And you can see different lessons. The first one being triggered as in progress. Of course, this is static for now, even though it's pulling real data from our application, but we can't do anything within it yet. This might look a bit different on your end, and you can definitely go ahead and make some tweaks. Like, I can see that the top image right now is being cut off, so that's exactly what I'll tell it. The top of the image on the lesson screen is being cut. Make sure that the full image is visible. And you can go ahead and add a couple of these corrective prompts so that it fixes itself. We can also compare it to the final design that we had in mind right here under the lesson screen. And you can see that we're missing some kind of checkboxes, but maybe they're going to appear after we complete this current lesson, for which we need to show some kind of an image telling us what it is all about. And in this one, you can see how it's showing at a cafe. Here we have greetings, which is okay. But let's see if maybe it could have used some other images from the assets. So if you head over here, we're looking at mascot welcome, logo, palace, and then treasure and streak fire, which we can use for some other things. But no, I like this palace one that it used. It can be used for the greetings. Later on, we can generate a lot more images for all of the other lessons and everything else we're working on. And after 2 iterative prompts, we fixed it, and now the image is visible. And I get that this specific image doesn't look the best. There's some empty space right here and so on. But the point of this is for you to figure out that generatively, using AI, we can generate assets that would be perfect for every single unit. So if you're learning about buildings, we can show a building. If you're learning about greetings, we can show this little, 400 pixel by 100 pixel banner at the top to make our application that much more interactive. And yeah, this is it. This is the unit or lesson screen. Now, immediately, we can move over to implementing the next screen as they're kind of connected. If you head over into your prompt materials, you'll see the 07 audio lesson screen. And this one is all about talking directly to our AI teaching assistant. So it means we'll have some kind of microphone actions, subtitles, and then additional language learning specific features. So go ahead and open up prompts. After the lesson UI, we have the audio lesson UI. And the goal here is to implement the AI teacher audio lesson screen exactly as shown in the attached design, so that when the user taps any lesson from the Learn lesson screen, the one we developed right now, it opens up the screen with the selected lesson ID and display the selected lesson's language, title, goal, phrases, and the AI teacher context from the hard-coded learning data. This should be an audio-only experience. Do not implement the video calling for now. Keep the camera area as a visual teacher preview placeholder only if needed, and focus on audio lesson controls such as mic, subtitles, end call, lesson feedback, teacher response bubbles, and session status. Use the assets from the assets folder via centralized images, and keep everything consistent with the existing design system and bottom tab navigation. So go ahead and open this up within your agent and tell it to implement it, so that as soon as it is done, you'll actually be able to click and open all of these lessons. And in a couple of minutes, we have the new audio lesson screen. So go ahead and click on any of these lessons, and this is what we get. You can see the mascot right in the middle. Of course, we can change this later on, and we can even animate it or create some kind of tools so that it seems like it's speaking to us directly. There's controls for the camera and the mic, which right now are not functional. There's a button to be able to hear the translation. And at the bottom, you can see your speaking, pronunciation, and grammar rating. And at the top right, there's a placeholder for the camera if later on we want to make this interactive. Now let's compare this with the final design. It's great, but it looks like it messed up the buttons a bit. They don't seem to be attached to the full design. And I like how it has actually hidden the bottom navigation because we can navigate back using some other things right here. Yep, so this is working well. But again, it's just this part right here that doesn't seem to be the part of the rest of the screen. So I'll take this part right here, a screenshot of it, and drag and drop it into this chat while holding the Shift key. Then I'll also take a part of this one and say, the final camera, mic, subtitles, and end call settings are created within some kind of a darker rectangle, which doesn't seem to fit the rest of the screen. But on the other screenshot that I shared, which is the final design, they seem to be nicely integrated into the whole interface. Modify the design so that it looks more similar to the final one. And let's see how it does it. And while it's making the UI changes, you can already see how it's trying to fit it in more nicely. There we go. This is immediately looking so much better. So now it seems like a single part of the screen where these actions for the subtitles, mic, and everything else are a part of the experience. Sure, now we can move this mascot a bit up and remove the video playthrough at the top right. So that's exactly what I'll tell it to do. Center the mascot in this purple rectangle that you have vertically, and then also remove the video placeholder at the top right. And that's it. In a couple of seconds, it did it. With that in mind, we now have the UI for the units, including all the lessons together, and then also for individual lesson conversation screen, which is going to be the core functionality of our application. So let's get the code reviewed, and then immediately in the next lesson, we can start integrating our real-time AI conversation capabilities. For now, I'll go ahead and push all the code by running git add dot, git commit -m, implement unit and lesson screens, and then run git push. Then you can head over to your GitHub, open up this PR, and then let's give it CodeRabbit about a minute to review the code for these two screens and point out to any potential bugs or inconsistencies, which we'll then fix and move over to implementing the core functionality of our application. And in a couple of minutes, the review is in. In this lesson, we added the new screen with audio-based interactive learning experience. We expanded the course contents, added the lesson card components, added the mic and subtitle toggle controls during lesson, and improved the learning interface. So let's go through the review. There's a little issue where we're rendering static content no matter which language was selected. You can see that here. But this is something that we're going to update later on as we continue adding more features. Then we have the incorrect Japanese phrase contents. I love this. CodeRabbit isn't just good at fixing bug, but also grammar. So once we're ready to move the app to the market, we can be sure that whenever we add some new content, CodeRabbit will also check its grammar. But yeah, with that in mind, we're good to merge this. And in the next lesson, we'll dive right into adding the functionality to our app. At this point, the front-end MVP of the application is mostly complete. There's authentication with fully persisted onboarding flows and lesson selection screen. Then there's the Learn page with all the lessons and different units, as well as the AI teacher lesson, where soon enough you'll be able to communicate with the agent. So that's the next step, finally connecting the app to real-time AI infrastructure. And for this project, I decided to use Stream alongside their new Vision agents. The reason I like this is because Stream already handles a lot of difficult real-time communication problems for us, such as the audio session infrastructure, like handling the triggering of the camera, microphone, and so on, as well as the participant state, so you can know when additional participants join the call, low latency communication, connection lifecycle, so when person is joining, when they exit, and so on, and all of the real-time events within the chat. Which means that instead of building a real-time communication system from scratch, which could take literally weeks up to months of infrastructure to set up, we can focus more on the learning experience or the conversational flow of the app. We can focus on the AI teaching interactions and the user experience of our product. And architecturally, this fits perfectly with the way we've been building the app so far. So to get started with this, I'll install the official Stream agent skills, because it'll give us a cleaner documentation that'll help us set up audio and video calls in any kind of applications using AI agents. So go ahead and install it by heading over into your terminal and running npx skills add getstream agent skills. You can select Stream, Stream Builder, CLI, and Docs, as well as React Native. Press enter, choose the agent you want to install the skills for, and just press enter until it finishes. Then, if you haven't already, go ahead and click the Stream link down in the description and create your free account. Then, at the top right corner, create a new app. You can call it JSM underscore whatever name of the app you chose. Set it to development for now, and choose the region that is closest to you. And create the app. While it's being created, you can enter that project, and then copy the API key and secret, and move it over into our envs. So right here under our env, you can add the Stream API key and paste the one you copied, as well the Stream API secret. This is going to be that longer code that we copied from here. So now that we've set up our account, project, and connected the envs, in the upcoming lessons, we'll start connecting it. Up until now, everything we've done was through JavaScript and Expo-supported APIs. So having Expo Go on your phone was enough to test the app. We just ran npm run start. It would trigger the Expo, allow you to scan the code, reload it, and it was there. But many developers want to go a step further and get access to full native modules that need to be compiled into an app binary. So Expo can't load arbitrary native code at runtime. Like many powerful mobile native libraries and SDKs, Stream's real-time audio SDK also requires that. So from this lesson onward, we'll use a development build instead. Same experience with Expo, same hot reload, same Expo router, and same project, just compiled with the native modules included. And whenever I did a React Native app with Expo, people on YouTube have been begging me to also do a native build throughout both platforms. So for a native build environment, you need to pick the platform. If you're on macOS, go ahead and use Xcode. It builds for iOS Simulator and iOS devices. If you're in Windows or Linux, go with Android Studio, which builds for Android Emulator and Android devices. But if you're in macOS and want to target Android too, you can also install Android Studio later. For this lesson, Xcode is going to be the easier path because Apple only allows iOS builds on macOS, and you already have the operating system. And that's what I'm building on right now. So depending on your setup, you might want to set up either Xcode, which is what I'm going to guide you through, or set up Android Studio. And there's plenty of guides online on how to do that. So I'll now go through path A, macOS and Xcode. If you're in Windows or Linux, go ahead and pause this video right now, find a guide on how to set up Android Studio. I might link some guides into the video kit link down in the description. And then once we're both done with our setups, we can continue with the build. Step 1 is to open up your App Store on macOS and search for Xcode. You can simply get to install it right here. It'll start the download, and it might take some time depending on your internet speed because it has almost 13 gigs. Yep, running simulators isn't easy. So this really shows how powerful Expo is. Once installed, you can just open it, agree to sell your soul, verify soul selling with a password, and then select the components you want to install. Don't forget to also add iOS right here so that we can test those things. Go ahead and download and install. And it looks like Xcode is diving a bit deeper into agentic coding through OpenAI codecs and Claude agents directly within Xcode. It's impossible to develop without AI anymore. So let's wait until the iOS simulator finishes downloading. Then we'll restart our Xcode and we'll be able to run our simulator. Then the next step is to install Homebrew. Homebrew is a package manager for macOS or Linux, allowing you to more easily install some programs. So you can copy the installation command from the website, then open up your terminal, and maybe you already have it installed, so you can run brew with a V flag to see whether you get back a version. I already have it installed. Then we want to install something called CocoaPods, which is a dependency manager that links native iOS libraries into your Xcode project. So within the terminal, you can run brew install CocoaPods. It's going to auto update as I didn't use it in some time. And then once it does, it'll install that package, which will allow us to move over our React Native modules that ship Swift or Objective-C code and make it reliable. Once done, you can run pod -- version to verify you have successfully installed it. If you get some numbers back, that means that you're good. Open up the terminal, run npm install to install all the dependencies within the project. And once they're installed, go ahead and run npx expo pre-build for the iOS platform with a clean flag. Pre-build will take your expo config and create a full iOS folder, and clean will wipe out any old generated code, so you start fresh. It'll say we have some uncommitted changes, so I'll say stop for now until we commit them. I'll run git add dot, git commit -m, start setting up stream, and then run git push to push all those changes over to GitHub. Now we can run that npx expo pre-build command, and it'll say cannot automatically write to dynamic config. Add the following to your expo config first. So we have to add this bundle identifier. I'll copy this part, head over into our app config, and then right here under expo and under iOS, we'll have to add the bundle identifier. So find the iOS part. It's going to be right here below. And alongside supports tablet, also add the bundle identifier. Then rerun the previous command. Now it'll again say that the branch has uncommitted file changes, We can go ahead and continue, and it'll finish the pre-build, install the pods, and it'll allow you to open up your iOS project in XCode. Once that is done, head back over to XCode and click Open Existing Project. Then find your codebase and click Open. You'll be able to see your full project right here. Now, within the top options at the top left where it says XCode, go ahead and open that window, then open the developer tool, and finally head over to Simulator. That'll immediately spin up a new iPhone device on your screen. And this one will act and behave much more like a real iPhone device than what you're seeing on Expo Go. Of course, that is Apple, and they make that connection from macOS to iOS seamless. And of course, if you're on Android, you can also spin up any kind of a device like a Samsung or a Google phone to be able to test your application on it. Let's wait until it boots up. So once it boots up, you'll see a new iPhone device that you'll be able to scroll through naturally, even using your mouse, which means that I can stop mirroring my Expo device and pull this one right here. So now the question is, how can we run our Expo app within this iOS simulator? Get back to your VS Code and simply run npx expo run iOS. This will try to build a native iOS app using Xcode tooling. But you can see that there's no code signing certificates available to use. So to fix that, simply head back over to Xcode, open up the settings, then head over into accounts and sign in with your Apple account. You'll have to enter your email and password. Then back within your VS Code terminal, you can type XED iOS, which is gonna open up your Xcode alongside this window for choosing the simulators. Choose the iPhone 17 Pro, and then under Sign In and Capabilities, you can connect your Apple development account and choose it right here under the team. And then you'll be able to come back and run npx expo run iOS, which will build the native iOS app using Xcode tooling. It'll start the Metro bundler, install the app on the selected simulator, and launch it automatically. And this process will take some time, as it has to compile a lot of stuff and make it work with the iOS simulator. In the background, I'm not sure if you're gonna hear that, but I can definitely hear it. My MacBook Pro fan also started spinning around much faster, which means that there's a lot of stuff happening in the background. Once again, Expo handles that for you by moving it over directly to your phone through Expo Go so that your device doesn't have to run all that processing on its own. But yeah, let's wait until it finishes, and hopefully we'll be able to run our app directly on this simulator. And as we waited a bit more, we are back to the typical Expo interface, but now it says Metro waiting on here, installing on iPhone 17, opening on iPhone 17, and it's asking us to give it access. So once we did, check this out. It all works so seamlessly. It's opening up, and we're greeted with a little error to start with. But that's good. At least we're within the app. To fix this issue, uninstall, rebuild, and restart the app. Or if you're using CocoaPods, run pod install in the iOS directory, and then rebuild and rerun the app. In this case, it's referring to the React Native async storage. So what we can do is basically install it. I'll open up a new terminal on the side to run it. npx expo install add React Native async storage like this. This will install it. And as soon as that is done, I also want to run cd iOS to move into the iOS folder, and then run pod install there, and then cd out of it. It'll analyze all the dependencies and make sure that the simulator has access to everything it needs, such as the React Native async storage. This is happening because PostHog's SDK depends on async storage internally, and Expo and React Native Autolinker only links to native modules that are direct dependencies in the package JSON. So adding it explicitly tells the Autolinker to wire it up on the native side. And then pod install rebuilds the iOS bridge to include it. Once that is done, you can close this terminal, head back over into the original one where we are running the server, and simply run npx expo run iOS, which is gonna rerun it with this new package installed. And once it reinstalls it, it'll try to reopen it on the simulator. And here we are, back on our onboarding screen. This is just amazing. You can also open the debugger to view the warnings, and you can now interact with your screen right with your mouse. Let's continue with email and password. And this is pretty cool because you can now use your keyboard to interact with your phone. In this case, we can simply log in because we already created the account before. That'll send us over the code. Once you get it via email, you can simply paste it right here, and this will bring you into your language selection screen. So now let's go ahead and choose something like, let's go with Japanese. And we're learning Japanese. So now you can head over to Learn, and you can see all of the lessons, as well as open one of the lessons to start communicating with your AI agent teaching you the actual language. I mean, just how amazing this is. I am now running this device on an iOS simulator. Hopefully you set up yours as well, or if you're in Windows or Linux, you set up Android Studio by following the Expo documentation on setting all of it up. They've documented it very nicely, so you should have no trouble following along and getting to this point of the application. But yeah, once you're off Expo Go and once you're running it in a development build, be that on whatever operating system you have, we are ready to proceed to the next lesson and start implementing our low latency AI voice language teaching feature. Now, before writing any implementation code using AI, I first want to explain how this architecture works because understanding the flow is really important. The Stream React Native SDK handles real-time audio sessions, participant state, connection lifecycles, audio controls, and low latency communication, and so on. Importantly, Stream authentication requires secure user tokens, and those tokens should never be generated directly inside of the app, as that would expose your Stream secret key publicly. And that's exactly why we'll use Expo API routes. Basically, Expo app requests a Stream token API route. Then the Expo API route generates that token securely server-side, the client receives the token, and then Stream SDK joins the call using that token, similar to Next.js. And as a developer, I'm aware of this. But if you don't know or understand this, you can go to the Stream docs and just ask their AI. You can ask it about any questions you have. But for now, I just wanted to verify that what I said is true. So I'll ask it whether it's true that we can use the Expo API routes to solve this problem. And it says that is correct. So the authentication flow is correct. And there's even a documentation page that refers to this server endpoint as a token provider. A token provider is an endpoint on your server that can receive the info, validate it, provide a user ID, and then return that token to the frontend. Using Expo API routes for this purpose is a valid approach. So once you have the token, you can simply connect it using the connect user. So let's ask our agent to implement it for us by heading over to, we're already at 13, Stream Integration, where we want to tell it to use the installed GetStream agent skills and the Stream docs to implement the Stream audio call setup for the selected lesson flow, so that when a user taps a lesson, it keeps the existing audio lesson screen UI and adds the ability to start, join, mute, unmute, and end an audio-only Stream call. We want to use the Expo API routes for Stream token generation and call creation without exposing the Stream secrets in the Expo app. Use the selected lesson, selected language, and logged in Clerk user when creating the call in the session. Preserve the UI, and add clear loading, joined, error, muted, connecting, and ended states for the user info on the UI. So we're gonna one-shot the full end-to-end latency conversation with Stream right now. I'm gonna open this up and ask Claude to implement it. Now it's asking me whether it has the permission to use the skill Stream React Native, which is gonna help it implement it. Yeah, I'll say, of course, go ahead. And I believe this was the longest time that it took it to go through a single prompt. First, it took a long time to read through all of the docs, and then once it had everything, it said, okay, let me integrate the Stream audio call integration step by step. So the step one was to install the Stream Video React Native SDK packages, then update the app config to use the Stream plugins and API keys, update the env example with Stream keys, create the token for server-side generation, and then rewrite the lesson with the Stream audio call integration. It went through all the steps, implemented it, and then at the end, it came back with a full report. I think this is the first time in the video where the report is not in plain text, but rather a markdown, so that we can more easily read what happened. It created this new API route, which I explained why we needed beforehand, to generate that token and send it back so that we don't expose it publicly through the Expo app. Then it rewrote the actual lesson to include the full stream audio call lifecycle, such as the connecting, the joined, and the error, and we're ready to test it out. So before, stream video requires native code, which means that we must run a development build, not Expo Go. So we have to rerun the app with npx expo pre-build clean to clean it up, and then run it once again, either on iOS or on Android. So let me go ahead and open up the terminal, stop it from running, and run npx expo pre-build clean. We're going to run it with uncommitted changes, and it says that it cannot add it automatically because this part right here is missing under the Android packages. So I'll head over into the app config. Similarly to what we added to iOS, we can also add it right here to Android. Package is going to be set to the com.js mastery Duolingo core. Now, rerun the command, and it'll proceed with the pre-build process. Let's give it a minute. There we go, and once it is installed, you can simply run npx expo run iOS or Android. Again, we have no code signing certificates, so make sure to open up your app and make sure that you select yourself as a team right here. Then you can go ahead and rerun it. It'll plan the build and push the application to your simulator. And after some time, it looks like we got an error loading the Metro config because we're missing the React Native CSS Metro package. I think this is because of Nativewind version 5, as it splits the CSS processing engine into a separate React Native CSS package. So it's a peer dependency, but we need it right here if we're trying to run it on iOS. So simply run npm install React Native CSS to install it. Once that is done, you might need to add it to the pod by cding into iOS folder and then running pod install to install it there as well. And once that is done, you can rerun npx expo run iOS. Let's hope it'll spin it up properly on our simulator. And our app is now live on the simulator. So let's go ahead and test it out by heading over to the Learn tab and then navigating to the current lesson. You can see that it's connecting, setting up your lesson. Then it'll ask us whether we would like to turn on the camera. I'll say sure, go ahead. Next, our simulator is asking us whether we want to give it permission to access the microphone. So I'll allow it. And it says audio lesson is in progress. You can mute your mic. You can see that we're in the audio call right now. And you can also try to end the call. Once we end it, we get a little error saying cannot leave the call that has already been left. But overall, the connecting statuses work. You can join, you can turn on the mic, and you can exit the call. Let's just fix this little issue when I click the exit button that it thinks that we already exited it. So I'll copy this error message, navigate over to my last Claude chat, and tell it when I click the red disconnect button, this is what I get in the terminal. And now we can just paste this error. Let's see how it approaches it. It did it in like a couple of seconds, and it looks like the fix was 2 lines of code. After handle leave runs, the refs are null, so the use effect cleanup becomes a no-op instead of calling the leave a second time. So let's retry it. We join, connecting status is turned on, and after we're online, we can now safely exit the call. This is amazing. And if you're wondering about changes that were made directly within the code, at any point in time, you can ask to explain each generated file, including the reasoning, architectural choices, and more, and it'll immediately give you a file-by-file breakdown. Hopefully, I already explained why we have this stream API token route in detail. But again, if something is left unexplained by me, you can very easily get an additional explanation. So once you're happy with what we have so far, in the next lesson, we can move over to making this agent actually speak to us and teach us Japanese. Right now, users can join the audio sessions, but there's no AI agent inside of the call teaching them. And this is where vision agents come in. The role of the vision agent in this architecture is very important. Stream, as we learned, handles the transport, the audio infrastructure, the real-time communication, and more. But the vision agent becomes the AI participant that actually joins the lesson. So architecturally, there are 3 different layers. Expo app is the front end of the application. Stream powers the real-time audio transport, and then the vision agent is the AI teacher logic, or it can be a golf coach, or a phone support agent, or an interactive avatar, which would be interesting to see within our application as it can respond in real time with voice and video, and in this case, well, teach us a language. And if you do some further digging, you'll see that Vision Agent run as its own Python service, responsible for joining stream calls, processing real-time audio, interacting with OpenAI real-time, so we'll use OpenAI key here, but you can use any AI service, generating the responses, and managing that conversational teaching flow. And that is also why I'm going to teach you how to create a separate Python service. And no, you don't need to learn or do anything related to Python. That's the beauty of agentic development. This is going to be a classic case of how to use AI even when you're not aware of technology syntax like Python. You just need to understand what you're building, understand the logic, and the features you want to implement. That's enough to get things done using AI. So now, let's create the actual Vision Agent service that'll become the AI language teacher inside of our stream sessions. First, you can open up a new terminal and install agent skills for Vision Agents by saying npx skills add https://visionagents.ai. Press enter a couple of times. They'll be installed. And with that, we are ready to implement Vision Agents to act as our language learning teacher. So head over to prompts. Specifically now, we are under lesson 14, Vision Agents. And the goal here, to use the installed Vision Agent skill to create a Python service at Vision Agent folder inside of this repo. It is the AI language teacher, voice only, using OpenAI Realtime as the LLM and Stream Edge for transport. Reuse the Stream API key and secret from the parent env and add the OpenAI API key. By default, the teacher always speaks English and teaches the selected language through English. So before writing any lifecycle code, verify the join and other lifecycle method shapes against the installed SDK in this repo and confirm it starts cleanly. Go ahead and open it up with your agent and tell it to implement it. And while it's doing its thing, you can head over to platform.openai.com and create your account if you don't already have it. Then, once you log in, you can head over to the API keys, create a new secret key, give it a name of something like Vision Agent, and create it. You can copy it, open up the File Explorer, head over not within the env that's at the root of the application, but rather the env that is within this new folder that we're creating. It's going to be a folder called Vision Agents. So wait a bit until your agent creates it for you, as it did for me right here. And then within it, add a new .env and paste this key you just copied and call it OpenAI API key. Then let's let it do its thing. And this one took some time, but we implemented a whole new service that can act as an agent that joins our conversations. So after all of these code changes, it successfully implemented a Vision Agent Python service. It has a main Py file, which is the actual agent using the OpenAI real-time speech-to-text configuration over GetStream Edge. It parses the language from the call, waits for the student to join, and then sends simple responses to kick off the lesson. Can you check out this main Python file? I mean, sure, you can take a look at the code. Python is very English-like anyway, so it shouldn't be a problem for you to understand it. But of course, if you want to understand it in a bit more detail, you can always ask it to explain it to you in more details. So we have added our env key, and the next step is going to be to run the agent. I'll copy this command that it gave me right here. You can check how your file is called, main.py for example. Then open up your terminal, paste it right here by running uv run main.py, serve, and we're going to serve it on localhost 8000, and press enter. It's going to say that there's no main.py file found, so we simply have to point it over within the Vision Agent folder. So simply say vision-agent/main.py, and now it was able to find it, but it cannot find the .env package. So I'll simply copy this error and paste it back to the agent. It'll quickly figure out what's happening. It must be executed from within of that folder. So let's say allow running it from inside. And there we go. It says works fine from inside of it. So what we'll do is first, again, open up the same terminal, cd into Vision Agent, and then run the same command. Now it started the process, and the server is running. So in the next lesson, let's finally connect it to the lesson page UI. Right now, when a user joins the stream call, the Vision Agent service exists and the stream sessions work. But the AI teacher isn't automatically joining the same lesson session as the user. And this lesson is where everything finally comes together. The architecture flow now looks like this. The user opens the lesson. Expo app creates and joins the stream call. Then the Expo API route starts the Vision Agent session. Finally, the Vision Agent needs to join the same stream call. The lesson context gets injected into the call, therefore giving the AI teacher the data it needs to start teaching. Throughout this, we're basically creating a lesson-specific AI teacher aware of the exact lesson that the user opened. So let's connect everything together. By heading over to our prompts, that's going to be prompt number 15, connecting to UI. The goal here is to use the installed Vision Agent skill and stream skills to connect the audio lesson screen to the Vision Agent so the AI teacher joins the same stream call as the user. So add the Expo API routes to start and stop the agent and proxy to the Vision Agent server. Then pack the selected lesson, language, goals, vocabulary, phrases, and AI teacher prompts into the stream's call data so the agent can read it on join. We're making it so powerful and knowledgeable. Then update the Python agent to actually consume those fields. Make sure the agent has permissions to publish audio in Audio Room, like admin and go live, and then clean up the agent session both when the user ends the call and when the screen unmounts. Do not expose any secrets in the mobile app, keep the existing stream audio flow intact, and show the agent connection status with idle, connecting, connected, and failed states. Open that up within your agent chat and tell it to implement it. It'll start reading through your instructions, check out the AGENTS.md file, and then it'll start checking out the Vision Agent and data files, and finally the skills needed to implement it. And after about 5 to 10 minutes, it's done. Here's a summary of the changes we've made. The lesson page changed. Now we have different statuses: idle, connecting, connected, and failed alongside the call status. After joining the stream call, packs the full lesson context, that's amazing, into the call update through the custom object. The start agent session now drives the agent status transitions from idle to connected or failed. And it also updated the Vision Agent to fetch all of this custom data and use it. So let's try to join again, and you'll see agent unavailable. So go ahead and open up your terminal, stop it from running, and rerun it one more time. But we can run it in a simpler way just by saying something like uv run main.py serve, like this. Again, make sure that you're in that folder. And now we have to connect that agent with the app. I'll copy this Vision Agent information on how and where we're running it. Then I'll head back over into our previous Claude window. That's going to be right here, and tell it this is where we're currently running the Vision Agent. But when I join the lesson, it says agent unavailable. Then it'll check our React Native application and see if we're listening for the Vision Agent on a proper port. And after a bit of trial and error, there are no longer any errors. The call update is now wrapped in a try catch, so if stream rejects the update because of permissions, the lesson continues and the agent uses default prompts. Then is switch over the port as it avoids the macOS IPv6 issue where localhost resolves to 1, but UVcorn only listens on IPv4. So, to debug, when you join the next session, look at the terminal where npx expo start is running. You should see either starting session, session started, or failed. And in the device simulator console, check whether there's an API error or a fetch through. So we can open up the terminal right now. This is the terminal where we're running the Vision Agents. I'll also split it with the other one where we're running our application. Rerun the server right here. So we start clean, And I'll also go ahead and rerun the vision agents as well. And once it does, we're back into the application. You can also launch the DevTools if you want to, so we have an additional point of reference to track if something goes wrong. And now you can head over to Learn, go into the lesson, and we can track what's happening on the backend side. It says joining the call. Okay, this is great. So maybe we just needed to restart our application, and then it worked. It successfully connected it, and we were able to join and exit the call. Now, the agent's voice and the way it speaks to us still isn't quite where we want it to be. So in the next lesson, we'll improve that AI teacher. But already, we have a lot of code to review. So let's first commit it, push it, and review it, and optimize how our AI teacher speaks to us. I'll create an additional terminal and run git add dot git commit -m implement stream vision agent AI language learning teacher, and then run git push. Back within our application, compare the changes, and open up a new pull request. We had plenty files changed because we installed a couple of different agent skills. Those don't necessarily have to be reviewed, but they're adding to the amount of stuff that CodeRabbit has to go through. And very soon the review is in. This was one of the biggest lessons so far, where we added an AI agent session management for real-time voice and video interactions by integrating Stream video calls through Stream API token generation, and most importantly, through Vision agents. So now we can go over all the recommended changes. First, there's a couple regarding the skills, but we're not gonna touch those as that's not the code that we created. But immediately after, we have one within our one and only API route. This is a major potential issue where we shouldn't return success when session teardown fails. At line 66, that is right here, we return a response of OK is set to true. But instead, right here in the catch, we should be throwing an error so that we never actually reach this response JSON OK set to true. So let's quickly head over into that API file. That's going to be the agent session API. And we can head down below where we have this catch and the OK. Here it is. And right at the last catch, we can return response JSON failed to fetch vision agent. Then there's another one right here within the stream token API route, where we shouldn't mint stream tokens from an untrusted query user ID, because line 28, that is right here, accepts the arbitrary user ID, and then line 41 signs a valid token for it without binding to the authenticated caller. This allows impersonation and unauthorized call access. So instead, we should first authenticate that user. Only when they're authenticated, then we should create a token. So let's go ahead and make those changes. I'll ask AI to do them by heading back within our application, opening up Claude or whichever agent you use, and pasting this CodeRabbit suggestion. This was actually a great find and a security vulnerability within our application. Immediately, it confirmed the issue, and it's checking which authentication framework we used. After figuring out that we're using Clerk, it'll fix the issue that CodeRabbit nicely pointed out to prevent users to impersonate other users and perform some malicious requests. After doing some further digging, it has the full picture, and it confirmed the issue. The endpoint trusts the user ID from the query with no auth check. Since the project uses Clerk but has no Clerk backend installed, the fix requires to verify a Clerk JWT from the authorization header using Node's crypto create public key against Clerk JWKs. And then on the client side, send that Clerk session and verify it. So it's going to implement everything and update the client to send the Clerk session token in authorization instead of the user ID in the query. And if you're not a senior developer, understanding what's really happening here is going to be a bit more difficult. But I mean, that's exactly why we have CodeRabbit, to catch and fix these issues for us. So both files are there. So now before we enter a specific lesson, we're actually authorizing the users. Let's not forget to restart the application by running npx expo run iOS one more time so that we can test it all out. And once the new packages are in, we can once again join the session. Continuing with the other issues, here we have some missing effect dependencies in lesson ID, where we're currently only updating it on the isLoaded state, but if the user or lesson data changes, we don't update the agent. So we're gonna update the dependency array right here in the user ID page. Let's search for it properly, or that's going to be the lesson ID. And if you scroll down to this use effect, you'll be able to see the one where we only updated on is loaded. Here it is. And even right here, if you hover, it says that we need to add the others. So let's go ahead and update it. And finally, the last one is in Python, where it says that if we're missing environment variables, we should fail quickly. So the only thing we have to do is add the checks for missing environment variables. So I'll copy these pieces of code. This is in the define language name. Head over to main.py, where we define the language name. I'll paste it here. Remove all the X's at the top because we're adding those additional lines. This has to be above the function. And then these if statements should be as a first part of this definition right here. Perfect. So with that in mind, we have implemented all the changes. I'll open up a new terminal, run git add dot, git commit -m, implement code rabbit suggested fixes, and run git push. GitHub will automatically recognize the changes and allow us to merge them. This is amazing. With one security issue solved by CodeRabbit, we are ready to proceed with improving the way that our AI agent interacts with the learners. We're very close to finalizing the app, but there's one thing you might have noticed about this real-time AI voice experience, and that is that the AI still feels a bit emotionally flat. And for a language learning app, that matters a lot. If the teacher sounds robotic, repetitive, too formal, too verbose, or just emotionally disconnected, the experience immediately stops feeling like an actual lesson. So this lesson is focused entirely on improving the conversational teaching quality. So head over into prompts, and this is going to be prompt number 16, AI teacher. The goal here is to improve the AI teacher's spoken output so it feels warm, human, energetic, and lesson-focused instead of robotic. Update only the Vision Agent kickoff prompt and the per lesson entries in the data lessons file. The AI teacher should act like a real-world language teacher for the currently selected language and lesson only. It should stay strictly within that lesson's goal, vocabulary, phrases, and context, and should not teach unrelated topics or switch to other languages. The teacher should mostly speak English, introduce the target language words slowly with translations, use short natural sentences with contractions and gentle encouragement, listen to the user's response, then adapt the next explanation accordingly, and ask the student to repeat or try again. Keep the replies to 1 or 2 conversational sentences. So let's go ahead and feed this into our agent by telling it to implement it. And it'll be interesting to see which actual changes does it make to make the agent more lifelike. And about a minute and a half later, it figured out what we need. So then it started rewriting all the AI teacher prompts. First, it modified the general one, giving it more info, such as you're energetic, you're in a one-on-one voice lesson, you speak mostly English and introduce target languages one at a time, say the word, give its English meaning, and so on, use contractions and friendly encouragements. After teaching each word or phrase, ask the student to repeat it out loud, and then if they struggle, say the same word again slowly, so you can see how big of a difference this can make. And then it updated each specific language teacher. Like Luna here, an upbeat Spanish teacher in one-on-one voice sessions. It added a couple more phrases. And it did the same thing for all the other languages. Spanish, French, Japanese, German, and more. So let's test out this new experience. I'll start a new lesson. Let's go with greetings.
Konnichiwa. I'm Yuki, your Japanese teacher. Japanese might look different from languages you know.
Okay. So
Konbanwa.
obviously this works incredibly well,
Good
but
evening.
as you can see, it's not
Repeat
listening
after
to us. It is just speaking its own thing. And while it's great to listen to it, that could have been a recorded session. So back within our application, head over into Claude. We'll open up the previous conversation we had, and we'll try to be very specific. Currently, it sounds like teacher just reads a lesson, like a recording, but instead, we want to make it an interactive experience. After the agent says something, we want to make sure that it listens and waits for our input. Then, after it gets information from our microphone, it should react accordingly. I'll send this out. It is possible that that's already working within the application, but the simulator microphone is not picking it up. So maybe we have to fix the input device instead. But let's see where this prompt is going to take us. And after a minute or so, it finished, but this just told it to be even more interactive. But before, it was not interactive at all. So I think the problem is that my mic was actually not getting picked up. And I told you that the iOS simulator is working incredibly well, but one thing that it is famously unreliable at is the WebRTC microphone connection. And Stream's own docs recommend physical devices for audio testing. So to test it out properly, open up your terminal where you're currently running the app. That's going to be this one here. And write npx expo run iOS device. But before you run it, make sure to connect your iPhone via a wire to your MacBook. That way, when you press it, you should be able to see it right here on the list. Adrian's iPhone, and you can see this wired connection. Now, if you're doing this on Android and your simulator is picking up your mic, then you don't have to do any of this. So let's proceed. And now it should build the app directly on our physical phone, which is great for testing anyways. And very quickly, the build fails as we haven't turned on the developer mode on our iPhone. So right here, it says head over to Settings, Privacy and Security, and then turn on the developer mode and restart your phone. So that's exactly what I'm going to do now. And when you try to run it afterwards, we have the issue regarding the signing profiles. This is very similar to what we had before with our simulator. So just run XED iOS, which is going to open this up. Then under Duolingo clone, select your device right here as the simulator, and then you have to add your signing profile right here. But even if we add this theme right here, it'll say that we cannot create an iOS app development provisioning profile for my specific profile. So what you can do is remove this sign in with Apple functionality by clicking on the trash icon, which will then give you the signing certificate. And now that we have fixed the signing permissions, rerun the command and select your device. And then it went through a couple of minute process of actually building it on my device, but we ran into another little obstacle telling us that we need to enable apps from untrusted sources. That's what it says right here within our device. So you have to head over to your iPhone settings one more time, head over into the VPN and device management, and then under developer app, you have to trust the Duolingo clone, which you just tried to run on the application. Once you do that, you'll be able to rerun this device. Once again, select your device right here, and hopefully this time it builds successfully. And this time, the app actually runs on my real device. And if you reload it, here we are. So let's get started, and let's sign in with our existing account. I'll go with Google. This Clerk authentication was super simple, bringing us back to the onboarding. Let's try to go with Spanish this time. Nicely brought into our homepage. Then we can head over to Learn, and the first lesson is all about greetings. And check this out. This pop-up is super important. It asks us for the access to the camera and, more importantly, the microphone.
Hola, I'm Luna, your Spanish teacher. Let's kick off our very first lesson with some greetings. First word, hola. Hola. That means hello. Please repeat after me. Hola.
Hola.
Next. Nice start. Try hola with a clean O sound, like hola.
Hola. Hola.
That was much better. Clear and confident. Keep that open O sound at the start. Great job today. You're off to a lovely beginning.
Okay, this sounds great. Are there any other greetings that we can learn about?
Yes. Let's add two more. Buenos dias. Buenos dias. It means good morning. Please repeat. Buenos dias.
Buenos dias.
Great attempt. Just one small tweak. The ue in buenos should sound like bue, not bu. So it's buenos dias. Buenos dias. Try again.
Buenos dias. Buenos dias.
Beautiful. That sounded clear and natural. Keep that smooth bue at the
Bue.
start and
Bue. Is that how it's supposed to be? Buenos.
yes, exactly. That bue sound is right. Now say the full word. Buenos. Buenos. Please repeat after me.
Buenos. Buenos dias. Buenos tardes.
Fantastic. Both buenos dias and buenas tardes sound clear and friendly. You've got the rhythm now. Great work today. You're picking up Spanish greetings beautifully.
Okay, this is amazing. And I actually enjoyed learning about Spanish greetings within an application that we made together in this video. I mean, how crazy is this? And now, if you want to learn a bit more about numbers, you just head over into lesson number 3 and see what it has to say.
Great. Let's go through 1 to 10. 1. Uno, uno. Repeat after me. 2. Dos, dos. Your turn.
Okay,
Three.
wait for me to repeat. 1 is uno, dos, tres.
Nice job. Keep it steady and clear.
Okay,
One.
let's go further. I think I know this, right? Uno, dos, tres, cuatro, cinco, seis, siete, ocho, nueve, diez.
That was excellent recall. Just one small tweak. 10 is diez, diez, with a soft yes sound, not diez. Try diez, diez. Everything else sounded really good.
Okay, this is absolutely amazing. Thank you for teaching me the numbers. Okay, this is working incredibly well. There might be a couple of hiccups here and there where our teacher hears itself and then responds back to itself as well. Not sure whether that's due to the simulator picking up its own audio through the mic or something else. But yeah, we can definitely tweak that further and play with it. If it's working a bit differently for you, go ahead and prompt it further and see how far you can get. In the next lesson, we'll add a little improvement to our AI teacher that will make a big difference in the usability and the conversation we're having. The first update we can make is a bit to the UI and a bit to the UX of the learning page. Now try to ignore what the agent is saying while I'm speaking, but you get the idea. Sometimes it hears itself speak and responds back to itself, and we want to fix that behavior. I believe how Duolingo and similar apps do it is that they have specific windows where the user speaks and where the agent speaks. So that way we can turn on or off each other's microphones. That's one way. And the other one is to clear up the UI a bit and then have a special press and hold the mic button so that whenever you want to say something, you press and hold it, and then the AI teacher stops speaking. So that way you have some sort of turns. And I think I might prefer that because it's going to be a bit more interactive rather than having a teacher speak and then asking you the question. This way, you can always stop it by pressing and holding the mic button. And we also don't need the camera, we don't need the subtitles, and we can move the end call button somewhere else. So let's modify the UI with that in mind. I'll tell it to, I want to change the UX and UI of the lesson page, specifically where we speak with the AI teacher. First of all, remove the buttons for the camera and the subtitles button, as we're not actually using those. Move the end call button somewhere else, maybe on the top right of the page. And that way, we'll have only a central push and hold mic button, so that when we push and hold it, the AI teacher stops speaking and it's listening to us. And that way, we don't have to have some kind of echo when the agent is speaking. It's going to improve the interactivity of the application without having that echo when it speaks to itself. And it's going to clear the UI a bit by removing these two buttons which we're not actually using. So let's see how well it does it. In this case, you can do it in the same chat as before, or you can open up a new chat, as this is somewhere in the middle of being a new feature and modifying the lesson conversation page. So let's see how well it does. And a couple of minutes after, it implemented some UI changes. End to call button is moved to the top right of the header as a red circle button. This is just temporary. We can later on move it back so it's easier to get it with our thumb. The camera and subtitle buttons removed. Controls row replaced with a single centered push and hold mic section. And this matters. Push to talk behavior. Mic is muted immediately on call join. This kills the echo loop where the agent was hearing its own voice through the device speaker. Then when we hold it, the microphone enable fires, the audio flows to stream OpenAI real time, and then it detects our speech and automatically interrupts the agent. When we release it, microphone disables. And then this brief silence tells the agent that your turn is done, and the agent generates its response. This also brings us some visual state so we know what is happening. So let's enter one of the lessons. You can see now setting up at the bottom, and it's going to start speaking without us interrupting it.
Hola, today we're counting in Spanish. Uno, dos, tres. Ready to try? Let's go. One is uno. Uno, uno. Please repeat. Uno. Great job. Two is
Okay, so even though I clicked the button and held it, it continued speaking, but maybe I wanted to interrupt it and say something. And even though now it's listening, I had to start saying something for it to start listening, even though it said listening as soon as I pressed it. So yeah, uno, dos, tres. Let me fix you and we'll continue with the rest.
Let me pause for a moment so you can jump in anytime you need.
Okay, let's go ahead and fix that. I'll tell it exactly what I said right now. Now, when I click and hold the button, it says listening, but the agent continues speaking and is not actually listening until I start speaking. So maybe can we interrupt the agent as soon as we press the button so we can say something in peace? And let's give it some time to implement it. As you can see, as we dive deeper into making our app truly functional and so that it has great UI and UX and so that people can actually learn from it, it'll require some back and forth to get your ideas put into place. But we're already making huge progress. And if you're watching this on Android Studio, you might be experiencing some different issue. Maybe not with Echo or with the microphone, but something else. Maybe the agent not connecting at all or something else. If that's the case, just prompt it further and try to fix it on your end. The goal of this video is not to teach you how to copy and paste some prompts, but to teach you how to approach making those prompts in the first place for whichever problem you're experiencing on your end, or not even problem for whichever features you want to add to your apps. After doing some research, the agent says that it has everything it needs. It needs to switch the Python agent from semantic VAD, which needs full speech intent detection, which is slow, to server VAD, which is energy-based and fires within 100 milliseconds of any audio appearing. We want to set the interrupt response to true so the audio's agent output stops the instant the VAD fires, which happens as soon as the mic opens and picks up ambient sound. And there we go. It implemented the fix. Let's hit the reload button or just press the letter R in the terminal, head over into a new lesson, and let's get back to maybe greetings to see if we learned about them. It's connecting and setting up.
Nice. Let's get started with some friendly Spanish greetings together.
Okay, let's get started.
Hola, I'm Luna, your Spanish teacher. Let's kick off our very first lesson with some greetings. First word, hola. Hola. It means hello. Please repeat after me. Hola. Great job. Next,
Hola,
buenos dias.
hola.
Nice. That was good. Hola. Hola. Keep the O round and clear, and the la light and smooth. Please repeat after me once more. Hola.
Hola.
Beautiful. That sounded smooth and clear.
Okay, this isn't bad, but there was one thing that I noticed. Somewhere in the script, it said great job or nice job before I actually said hola. So we need to tell it to modify the script not to say nice job before it actually hears what we said. Currently, the AI teacher said nice job without me ever responding back to how I wanted to say a specific word. So modify the script so that it doesn't preemptively say nice job or congratulate me for something that I didn't actually say. It needs to have some pauses for me to interrupt it and then give my feedback. This will get us one step closer to having that teacher-like experience. So it immediately made a change saying that we're having a real interaction. It operates in two modes, the teaching mode and the reacting mode, where we have received the actual speech from the student and now it's our turn to react. The pattern across all 15 lessons is the same. When they respond, react. And very quickly, it changed it across all the lessons. So let's give it a shot. I'll open up the introductions lessons this time, and let's see what it can teach us.
All right. Let's jump right in and start practicing your Spanish introductions together. Hola de nuevo. Today, we're learning how to introduce ourselves in Spanish. It's easier than you think, I promise. First word, hola. Hola. Please repeat after me. Hola. Great job. Keep the
Hola.
O sound.
Hola. Hola. Why did you say great job if I didn't yet say my hola?
You're right. I jumped in too early there. Thanks for catching that. Let's try again. Please say hola now, and then I'll give you feedback.
Okay, this is great. Now you're actually waiting for my feedback. Hola. ¿Cómo estás?
Nice work with hola. You sounded clear and confident. Now let's practice ¿Cómo estás? It means how are you in English. Listen. ¿Cómo estás? ¿Cómo estás? Please repeat after me. ¿Cómo estás?
¿Cómo
Great job.
estás? ¿Cómo estás?
That was very close. Your rhythm was good.
Okay, we're definitely getting closer. Sometimes the agent still jumps in a bit too early, and that's something we can continue tweaking as we go. But now I want to move to something which I believe is much more important. And for what I personally believe is the most underrated thing while building AI assisted apps. And that is knowing when to stop following tutorials step by step and start experimenting on your own. Because by now, you already have understanding of the most important moving pieces in this app. You've built auth, login screens, the homepage, and the learn screen. You've tested and tasted everything. So for this lesson, I want to approach things a little differently. Instead of immediately implementing the feature together, I want you to first try solving it yourself. This is where the idea of practical vibe coding actually starts becoming practical. The goal isn't memorizing prompts. The real skill here is to learn to understand how to guide the AI clearly using the context that it already has. So, the next challenge right here is how do we enable real time transcriptions into the existing application? So, when you join a lesson, try to somehow show what the agent is saying and what you are saying so you can display it on the screen and that way more easily have the conversation. Pause this video and try writing that prompt on your own. Once you do that, you can resume the video. Solution coming up in 3, 2, 1. There we go. So the prompt in this case can be simple, even though you might have something more advanced. But the goal is to use the installed skills for Stream and Vision agents and implement the real-time live captions in the audio lesson screen for both the AI teacher speech and the user speech as they happen. So we're talking about live captions. Let's go ahead and ask AI to implement this, and let's see whether it is this easy. And after a couple of minutes, now, as soon as we join the call, it'll also start the closed captions. And this is also coming directly from Stream. So let's give it a spin. I'll open up the numbers lesson. It's going to start setting up. And once we're there, let's see what the teacher has to say.
Nice. Let's jump right in and practice those numbers together.
And you can see the text. Okay, let's go ahead and practice the numbers.
Hola. Today we're counting in Spanish. Uno, dos, tres. Ready to try? Let's go. Number 1 is uno. Uno. Repeat. Uno. Nice.
Yeah,
Number two
I know. I have to repeat it first. But yeah, sounds good. But it seems to be that that there's a bit of a delay within the transcripts. So let's go ahead and fix that first. I want them to appear in real time as we're speaking. So yeah, as I told it, currently the closed captions are only appearing after the full sentence or paragraph has been spoken. But instead, we want to see them in real time. So as the words are being spoken, we want them to appear on the screen. That's how these real-time applications should work. And after a couple of minutes, we have the response back. Vision Agent SDK patch. It was receiving the response audio transcript events from OpenAI, but silently ignoring them via pass. So now we also added handling for the conversation item input audio transcription, which is the user speech. So each call now calls these with a mode of delta so subscribers can see these speech events immediately. I'll reload the application, open up one of the lessons, and let's see whether we can see the transcripts immediately.
All right. Let's dive right in and get those Spanish gradings rolling together.
Okay, it's a bit better. We can see it just after it finishes speaking. And ours comes almost immediately.
I'm only seeing a solid blue screen, so there's not much to go on from the image. If you'd like, we can keep practicing Spanish greetings. We've done hola and buenos dias. We can try adios next. Just say the word twice after me. and we'll keep it smooth and confident.
Yeah, this is much better. The responses are coming much more quickly, and I'm happy with this. Of course, we can always do some further tweaking, but this is more than good enough for now. Yeah, you can see how it's coming as I was saying it. Perfect. So with those additional fixes, it seems like the core functionalities of our application are getting more and more complete every second. And we'll get the code so far reviewed very soon, but before we do that, there's one more subtle but very important improvement I want us to make in the next lesson. Now, PostHog has been running within our application for a long time, capturing app opens and screen views. But that's just the bare minimum. The interesting question now is what users actually do inside of the lessons and where do they drop off? And we'll figure that out through a couple of different events, such as which languages do they select on the onboarding screen, and which lessons are they starting the most. From these events, we'll get a full onboarding funnel, as well as engagement signals for the AI teachers, and even retention curves by the language. The trick is to wire these correctly in the same practical vibe coding rule from the crash course. We don't tell the AI which files to edit. You tell it what it fires, when in the user flow it fires, and what properties to go with it. And then let it find the right places in the codebase to add it to. So head over into prompts and 18 more PostHog, and let's go through it together. The goal is to add PostHog event tracking to the existing app using the PostHog instance or the initialized. We don't want to reinitialize anything. Then, first, we want to authenticate the users after they sign in. Then, we want to capture 3 custom events. Language selected, this is on the onboarding screen. We want to know which languages are the most popular, so we can maybe hire more teachers from that language. How many lessons have been started, so we know what people actually want to learn about. Is it the greetings, the introductions, or the numbers? And then finally, how many lessons they have abandoned. And we can even track how long they have stayed within the lesson by capturing a ref on mount, so we get duration seconds. If you could track this, this could be amazing. So let's go ahead and tell Claude to implement it. And there we go. 5 changes across 5 files. First, we added the Clerk identifier component inside of the Clerk provider, which watches the user ID and the selected language, and then calls PostHog identify on every sign-in and sign-up, so that we know which user we're tracking. Then, when we're selecting a language, we're now adding a language name to the existing language selected capture. We're checking the preferred language and adding it to the identify call, and we're tracking the lesson start time and abandon. So what do you say that we go ahead and log out for a second? I think we need to reload our application for the logout to take effect. And then we can try to log in one more time to create a couple more events for us to track. Then we'll go over to the PostHog dashboard and try to make sense of all of those events. So as you can see, I'm navigating between different pages. Currently, the Spanish language has been selected. It might be interesting to make it clickable right here, this part on top left, to be able to change the language as you go, because currently this user is always going to remain on Spanish. But yeah, let's try to go ahead and open up a couple of lessons. Try to speak within a couple of lessons to see what is happening. Hola, hola, teach me something. There.
All right, let's jump right into our...
There we go. And we can enter another one to see how that goes. Perfect. And even one more. Wonderful. So we browsed the app a bit. We moved through a couple of screens. Let's see how PostHog is tracking those within the dashboard. And if you get back to your activity, you'll see that we have triggered many different events within the last couple of minutes, going all the way to the teacher, to the profile, to the chat, changing different screens, learning specific lessons in a specific language. And this is a lot of data to work with. So you could go ahead and create some insights on your homepage, or you can just navigate over to the chat. And we can ask the PostHog chat. And let's try to make sense of the data by just asking PostHog what we're doing. I'll use Whisperflow to use my natural speech instead of typing. Build me a dashboard called Duolingo Clone Core Engagement. And let's try to add as many useful insights as possible. Okay, so that's going to be the start. We want to have an onboarding funnel, which is going to be a conversion from the application opened to language selected to lesson started, and show conversion percentages between each step. This is incredibly useful to have. And hopefully it'll be able to figure out the events that we added to it so it can track all of those things. Also, I want to know the language's preferences breakdown. So that's going to be the breakdown of the language selected events grouped by the language name property. Simple bar chart sorted in a descending order. Something like that should do the trick. Then we also want to know where do users abandon lessons and the average time before abandoning. Maybe the most started lessons, like a bar chart of lesson started events grouped by the lesson ID. Show me just the top 10, the number of daily active users, and weekly retention. This is already a lot of data. So if we can extract all of this in literally a couple of minutes after implementing PostHog through their AI wizard, and then adding some custom events afterward, that will make a huge difference in allowing us to track the user behavior and continue implementing new features to our app to cater to the users who are using the app the most. So let's give it some time to find the events and the properties for everything I'm talking about. Keep in mind that I wasn't specific. I didn't tell it the exact names of how we're tracking the application opens or language selected metrics and so on. It needs to figure out that this lesson started is going to be maybe a lesson_started event. And it'll now proceed creating all 6 of these insights in parallel. Check this out. We got them immediately. There were just 3 users using the app yesterday, and 1 that's me using it today, as it's still being developed. But we can now track the daily active users as soon as we publish it to the Play Store. This is what I care about a lot. This is the full onboarding funnel, where 3 people have entered the application, 2 have selected languages, and only 1 has started the lesson. This means that we have to significantly improve our onboarding flow so that more users actually get to the main point of the application, which is actually starting lessons. Here we have the most popular languages, Spanish and Japanese. Specifically, lesson 2 in the Spanish language has been the most opened one, and the average amount of seconds after abandoning a specific lesson is 9 seconds for lesson 2, which means that it's much better from this one, which users abandon after 3 seconds. Of course, this is me just testing the app and jumping in and out of the lessons, but in real apps, this would be significantly longer. And it didn't just show us these insights on their own, but rather it created a new dashboard that we can open every time we go into PostHog that's going to automatically pull all of these insights in a single page so that we can have a general sense of how our application is going. And this is all the data I need to be able to make educated decisions on where to take the future of our application. So considering I've been using PostHog to track everything that's been happening on jsmastery.com for years now, and the fact that they have one of the best developer experiences amongst all the dev tools I've used, having PostHog as a sponsor to these videos couldn't be a more natural fit. So now that we know which features we have to focus on, let's do a final code review of all of the existing changes by asking CodeRabbit to review them directly within our VS Code. And would you look at that, we've been writing such quality code that there's only one single suggestion left for us to implement. And that one is none other than simply avoiding the any type right here on the TypeScript side of things. Thankfully, this is going to be a simple fix, as we just need to add an interface called stream custom event and then use it right here under events. So I'm going to copy it, mark this as done. Here, we're going to use the stream custom event, and we didn't have to even override anything because it automatically added the code pieces right here. There's just one little issue, which we can quick fix using AI to extend this type to also allow undefined speakers. There we go. So if there's nothing, it's going to just make it an agent by default. Great. So with that in mind, we can go ahead and push those changes by opening up our terminal, running git add dot git commit -m, and say improve the AI teacher conversations, as that's what we've done, and run git push. Now back on GitHub, since we reviewed the changes within the codebase, we can immediately merge this over to main quickly and safely. And believe it or not, with that, we came to the end of the video. I mean, yes and no. You've learned a lot by now. That much that I can trust you to implement all of these features on your own without any issues. So congrats on making it this far. But what you learned here wasn't just how to build this single AI app. It was more about how to structure the AI assisted workflows, how to think architecture first, how to break features into smaller implementation steps, and then guide AI using constraints and context. And also, how to build this real time AI powered mobile app through Stream and Vision agents so that it actually responds to what we're saying. Let's actually see what it's going to say to everything that just spoke to it.
Nice. Let's start with introductions, and then I'll weave in your AI questions in a clear, friendly way.
Okay, so it first wants to teach us Spanish, of course. But yeah, these skills you've learned are much more valuable than simply memorizing prompts. The real value is learning how to create systems that make those AI outputs more reliable and easier to iterate on. And if you notice throughout the project, most prompts were actually pretty small. What mattered more was reusable context that we gave our agent through the agents.md file, some architecture decisions that we made, feature isolation to only do one thing at a time, and consistency. That's the whole idea behind practical vibe coding, giving you development speed as well as a clear direction. Also, if you want to go deeper into this workflow, I created a practical vibe coding playbook, which includes practical app building workflows, reusable prompt structures, implementation checklists, architecture systems, project organization strategies, and templates you can use for your own apps. Basically, the exact systems and workflows I personally use while building projects like this. You can find it linked in the description below. If you want to see more videos like this, please tell me what you would like to see next. Definitely don't forget to join the Agentic course waitlist, as that's been our biggest project so far and it's coming very soon, which means that many more great stuff are coming to jsmastery.com. So if you watch this video until the end, I'm sure you're gonna love what's already inside and the stuff that's coming next. So thank you so much for watching. Amazing job on building this application with me, and have a wonderful day.